அதில் அப்போ நந்தாவோட தானே இருக்கும், எக்ஸ்ட்ரா இருக்குன்னா தெரியும் எனக்கு. இருந்ததுன்னா எல்லாத்தையும் சேர்த்து அதை தான் போட்டு வச்சுருக்கேன். யார் இது வாங்கி பேசியிருந்தது? ஓ கேமரா டிலே இருக்கு பார்க்குறேன். இப்போ என் கை வரணும்.
Good morning, ladies and gentlemen, faculty and honored guests. It is with great privilege that on behalf of Department of EEE, SRM Institute of Science and Technology, Marine Technology Society, India Section, and SRM MTS Student Chapter, we invite all our guests, special invitees, and participants to the inaugural function of MTS Techsurge, the Underwater Robotics 2026.
MTS Techsurge brings together young innovators and experienced speakers to share ideas, explore new technologies, and contribute to the advancement of marine science and engineering. We look forward to an exciting day of learning, innovation, and collaboration. Once again, welcome to MTS Techsurge 2026. I wish all participants the very best. We feel privileged to extend our warm welcome to one and all present here. We request the audience to rise for the invocation song, Tamil Thai Valthu.
தெற்கனவும் அது சிறந்த திராவிடனர் திருநாளும் தக்க சிறு பிறனுதலும் தரித்தனரும் திலகவுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மறக்க எழுந்த பெரும் தமிழனகே தமிழனகே முன் சீரிலமை
Now we request the MTS students to felicitate our guests with a bouquet. We request Dr. J. Peter Rosen, Chairperson of MTS India Section, to deliver the welcome address.
Good morning to one and all the distinguished dignitaries, respected guests, faculty members, and dear students. First and foremost, I thank the Almighty Lord for blessing us with this wonderful day and giving us the opportunity to gather here for this meaningful occasion. With great joy and heartfelt warmth, I extend a gracious welcome to MTS Techsurge 2026, the Underwater Robotics. Like the gentle waves of the ocean that bring together distant shores, this occasion brings together brilliant minds, inspiring experts, and passionate learners under one roof. Today is not just the beginning of an event, but the beginning of conversations, collaborations, and ideas that will travel far beyond this hall. We are deeply honored by the presence of our esteemed dignitary, Mr. Chris Ostrander, CEO, MTS India Section, MTS USA, whose wisdom and achievements inspire us to dream bigger and reach further. We welcome our distinguished guest, Dr. A. Shivatana Pillai, Sir C.V. Raman, Chair Professor, SRM Institute of Science and Technology, for this event. We are deeply honored to have you among us, and we look forward to your insightful words and guidance. It's my great pleasure to extend a warm welcome to Dr. Linus J. Sumartin, Dean CET of SRM Institute of Science and Technology. We are truly honored by your presence here today, and it is a privilege to have you with us for this important occasion. It's my pleasure to extend our warm welcome to Dr. Napoleon Dean Research, who has been supporting us by his constant encouragement. I extend my welcome to Dr. R. Venkatesan, Founder Chair, MTS India Section, who has been a constant guidance in getting success stories of MTS India Section. We wholeheartedly welcome our Chairperson, School of Electrical, Dr. K. Vijay Kumar, and our HOD, Dr. R. Sridhar, for their invaluable support and constant encouragement for SRM MTS Student Chapter. I sincerely welcome all the special invitees and industry experts who are here with us for sharing their invaluable sights and knowledge. I extend my welcome to MTS India Section branch councillors and MTS Student Section members and volunteers. I also welcome our student participants of MTS Nanda participants and poster participants who are the main audience for this event. On behalf of MTS India Section, it's my privilege to welcome you all once again. May this gathering be enriching, inspiring and memorable for everyone. Thank you.
Thank you, ma'am, for your warm and thoughtful welcome. We invite the delegates to enlighten the conference by lighting the Kuttuvilakku.
Now we would like to invite Dr. R. Venkatesan, Founding Chair of Marine Technology Society, India Section, to brief us about MTS Techsurge 2026.
Good morning. Distinguished experts on dais, Dr. Sudan Kulli, Dr. Linus Martin, Mr. Chris Ostrander, Dr. Napoleon, Dr. Vijay Kumar, Dr. Sridhar and Dr. Preeta. First and foremost, on behalf of MTS, I would like to thank the SRM management and the Vice Chancellor for supporting us in making such events to happen here. We are always privileged to have this support, and the MTS India section has grown for the past 10 years. This is the 10th year we are having this function here. It's mainly because of the support extended by the Chancellor, the management, in particular Dr. Vijay Kumar, who was there at that time, head at EEE. And of course, all the credit goes to Dr. Preeta, who has been spearheading this campaign, and she is holding the current chair. I always recall that after the inauguration, the first year itself, the SRM student section was suggested as the best student section all over the world. That's a major achievement they had. Subsequently, many of the students here could achieve scholarships. Even we had conducted MTS Vembu scholarship and the international scholarships and the training program, and many things were possible to support the student community by having these like-minded people working together on a voluntary basis. Today we have 10 student sections grown from this campus to many all over India, and all of them are contributing, and thanks to all the student section chair who have been spearheading their own activity. Tomorrow we'll have another program in IIT Madras. Dr. Sanesh Raj, professor, is handling. Day after tomorrow, Dr. Swagata Sarkar, she will be handling a program in Sairam Indian College. So, and also I would like to thank the MTS board and the president there and the CEO for all their support, and including their directors. Chris has been planning to come here for the past 2 years. I'm glad that he could come over here in spite of the global challenges what we face. He is here with us to share his experience and knowledge and motivate the young minds here. In particular, he'll be interacting with the startups so that what best the MTS students, the MTS India section can contribute, linking the startup in India and the startup in USA. He had done a very good program of linking 1,000 startups in Florida. That experience also he can share. And the MTS is connected to many funding mechanisms where there is a possibility of getting these supports. So there will be a good profile growth. His talk will talk about that. From a student to inspiring, how do you want to proceed? So there are more opportunities to come. Coming back to this Techsurge, this is a flagship program of MTS. We started it way back in 2016. Then President Dr. Ms. Donna, she came here, and we conducted a SAR program, Search and Rescue. Subsequently, we fisheries technology, we had the second Techsurge. Third Techsurge was held in the same place where we concentrate on A for the ocean. Subsequently, that culminated on the advice of Ms. Lenka Willis, who was then the president of MTS, as a conference. Today we are here on the fourth MTS Techsurge program. And similar like that, IIT Madras is handling TechSim, which is a student program. Tomorrow we'll have the fourth TechSim. And IIT Delhi conducts school student event. And Dr. Salim Anwar will be coming here from Aligarh Muslim University. He conducts regular program on underwater remotely operable vehicle, particularly in the hinterland. He supports that. In this way, we are all working together. We have the pleasure and joy of giving back to the society, particularly to the students. So with once again, I invite you all to this wonderful event today, and we will be having a more formal and informal discussion, and we are here to support you. Once again, thank you very much to all the faculty and the management of SRM for supporting us in this. Thank you.
Thank you for your thoughtful words, sir. We would now like to invite Dr. A. Shivadana Pillai, Sir C.V. Raman Chair Professor, School of Mechanical Engineering, SRM IST, to give the felicitation address.
Good morning to all the participants who have come all the way from different universities, different institutions to celebrate the MTS meeting at SRM. Respected Dr. Chris Ostrander, CEO of the Marine Technology Society, Dr. Venkateshan, Founder Chair, MTS India, Dr. Dennis Martin, Dean and the President of this session, respected Vijay Kumar, Dr. Vijay Kumar, Professor Sridhar, and very important person, Dr. Peter Rosalie, overall the chairman, Dr. Napoleon, who has just joined. and my dear friends. You know, the warfare is changing. For listening to the warfare which is happening now. In the warfare, we have got a theme: who controls the ocean will be the winner. And we have developed in India number of technologies which are required for the ocean warfare, particularly sensors, the sonars and other systems, buoys and other things. Then the underwater weapons like the torpedoes. Then all the materials which are required. Particularly we have developed robotics for underwater painting, and because we can't bring the ship all the time to the ocean, to the shore, so we have to do it in the underwater. And also we have developed certain technologies like AIP, air independent propulsion, which are required. Such technologies are very much required for the ships to be, or the submarines to be in the underwater for a long time. So like this, many technologies, particularly stealth technologies, have been developed in India, because we want to see that our warfare, the ocean warfare, is very important for us compared to the countries now which are now trying to say that this is our ocean. Each one is trying to dominate, like the Chinese saying that ocean belongs to them. Like that, many people are trying to do that. That is why India has to master the ocean technologies which are required. And the theme which has been chosen for this conference is very important: the underwater robotics. All the latest technologies which have been now developed for the robotic systems, which will be discussed today. Many presentations are there. I plan to give one after this session. I want to give one talk about the underwater robotics. So for the time being, I welcome all of you to one of the best universities in India, where we are trying to create centers of excellence. And one center of excellence is controlled by Dr. Rosalind, which is mainly the electrical system for naval applications. She is doing that work. Enormous contribution has been made by her. Recently, she has been selected as one of the best contributor award she got it. So that's what we are doing at the campus here. If you get a chance, you please see her laboratory. It is one of the best laboratories we have got today, the electrical engineering. Dr. Vijay Kumar will lead that. I think Mr. Martin should see, and then your press should see that. So, participation. Thank you for the organization. You give me a very short speech, but I will want to give a long speech. Thank you.
Thank you for your inspiring words, sir. Now we request Dr. R. Venkatesan to felicitate Dr. A. Shivatanu Pillai. We now request Dr. Linus Jesus Martin, Dean CTE of SRMIST, to convey the presidential address.
Good morning to one and all present here. Mr. Chris Mr. Venkatesan from both from MTS, Professor Dr. Shraddhan Pillai, my colleagues, members from NIOT and other organizations, the students and research scholars from other institutions. It's a pleasure for me to be part of this program, MTS Techsurge 2026, the one-day event. So on behalf of College of Engineering and Technology, I welcome all of you for the one-day program. I'm not going to take much time because I want other speakers to speak, particularly experts from other institutions, other places. They have traveled a lot. So I wish the organizers great success, and I wish the participants to have a wonderful day of hearing and seeing great things in front of you. All the best. Thank you.
Now we would like to call upon Mr. Chris Ostrander, CEO of Marine Technology Society, to deliver the inaugural speech.
Good morning, Dr. Pillai, Dr. Martin, Dr. Napoleon, Dr. Venkat, and Dr. Preetha, honored colleagues, members of the MTS India section, industry partners, faculty, students, and friends. It's a genuine privilege to be here with you in Chennai, a city shaped by the ocean, strengthened by innovation, and energized by one of the most dynamic anywhere in the world. Thank you. At the outset, I would like to respectfully acknowledge and thank our institutional partners, organizing committee members, faculty leaders, industry partners, and especially the volunteers of the MTS India section. Conferences like this do not happen by accident. They happen because dedicated people give their time, their expertise, and their energy to build community behind the scenes in service to something bigger than themselves. To our volunteer leaders and members across India, I thank you. Your commitment is the reason MTS continues to grow and thrive here. You represent the very best of what a professional society can be: locally rooted, globally connected, and forward-looking. I know there's a lot of students in the room, and many of you may be trying to figure out what comes next. I remember being there. Regardless of your plans, I believe many of you will go on to design the vehicles, the sensors, the policies, and the companies that people like me delivering solutions shaped by expertise and ingenuity developed along India's own coasts and within its own institutions. That's exactly why global communities matter. For more than 60 years, MTS has served as a neutral platform, connecting people, ideas, and technologies across the entire ocean enterprise. Our role is not simply to host conferences or publish journals. Our purpose is to create the conditions where collaboration can happen faster, where innovation can travel further, and where careers develop more intentionally. Because the challenges facing the ocean today do not belong to any one country or sector. Climate resilience, sustainable fisheries, ocean observations, marine robotics, these are global challenges, and increasingly they require global solutions built through partnership. And nowhere is that more evident than here in India. I've been looking forward to this visit because India's marine technology community, particularly in robotics and engineering, is advancing very quickly. And I'm here as much to listen and learn as I am to speak. Your marine technology community sits at a remarkable moment of engineering talent, a rapidly growing startup ecosystem, strong academic institutions, expanding blue economy ambitions, a national deep ocean mission that signals at the highest levels of government that India's future, just like its past, is connected to the sea. and a generation of students who are not simply asking what career they can pursue, but what problems they can solve. Events like this demonstrate something important. Marine technology is no longer a niche discipline. It is becoming essential infrastructure for economic development, environmental stewardship, national security, and scientific discovery. The underwater robotics community represents one of the most exciting intersections of engineering, AI, data science. The vehicles being designed, built, and deployed today are transforming how humanity understands and manages the ocean. And many of those ideas and many of those future leaders are likely present in this room. That's why the work of the MTS India section matters so deeply. Sections are where the global connectivity of MTS becomes personal. They create local lecture series. They mentor students. They convene startups and investors. And they create entry points for young professionals who may not yet realize they belong in this field. Professional societies succeed not because of headquarters, not because of staff like me, but because of communities like this one. Across India, MTS members are building bridges between universities and companies, between early career professionals and senior leaders, and between local innovation and global opportunity. And access to careers, access to mentors, access to collaboration, and access to markets. For students especially, and I know many of you are here today, one of the most important decisions you will make is not simply what you study, but who you learn alongside. Because marine technology is, at its core, collaborative. Your professional home matters. Through MTS, students and professionals gain access to technical communities led by global experts, scholarships and travel opportunity, robotics competitions that introduce thousands of young people to ocean technology every year, peer-reviewed publications through our journal, and leadership opportunities that allow volunteers to shape international conversations about standards, policy, and innovation. Many careers in this field begin with something simple: attending a section event, volunteering, publishing your first paper, or participating in a robotics competition. These small moments can become defining steps in your career journey. And I know this personally. Long before I became CEO of MTS, I attended my first section event as a young professional. I published one of my first papers in the MTS journal, and I met collaborators and partners along the way who would later become mentors and thought leaders with me. And at the time, I didn't realize those experiences were shaping my career. That's the power of community. It's also why gatherings like this matter so much, where researchers meet entrepreneurs, where students connect with employers, where startups engage investors, and policymakers and leaders hear directly from technologists, innovation accelerators, and ideas move from theory to practice. Over the next 2 days, whether here at this Techsurge or tomorrow at the TechSim, have a chance to on display. Companies deploying technology globally, startups taking bold risks, faculty pushing scientific boundaries, and students asking new questions. Each of you brings a different perspective, yet you share a common purpose: to responsibly advance our relationship with the ocean. As we look ahead, the opportunities before this community are extraordinary. Autonomous systems are expanding exploration into deeper environments. AI and advanced sensors are becoming smaller, more affordable, and more precise. Interdisciplinary collaboration is accelerating solutions across climate science, biodiversity, energy, and marine resource management. The future of marine technology will not be built by any one organization or nation alone. but through networks, partnerships, and communities willing to learn from one another exactly what we exist to meet someone new, ask a difficult question, including of me, share an unfinished idea, encourage a student, or engage a startup founder. Because the conversation you have over tea or lunch in a hallway may be the beginning of a collaboration that changes a career or solves a problem that none of us can solve alone. Before I conclude, I would like to recognize two community here in India. The MTS India section exists today because of the dedication of volunteers who believed in the value of building a professional community across this country. Two of those leaders are with us today. Dr. Venkat, the founding chair of the MTS India section, and Dr. Preetha, who currently serves as section chair and continues to guide its growth and impact. On behalf of me and on behalf of MTS, I would like to express our sincere appreciation for your leadership, your service, and your commitment to strengthening the marine technology community in India. As a gesture of gratitude, I have two small tokens of appreciation I would like to share with you both. Dr. Venkat, Dr. Preetha, thank you both for your leadership you have provided and for the community you have helped build. And with that, I look forward to the discussions ahead and to continuing our conversations in the sessions ahead as we shift our focus to career pathways and more. Thank you very much.
We kindly request Dr. Linus J. Martin to felicitate Mr. Chris Ostrander.
We wish to felicitate our branch counselors and members of the MTS section, without whom MTS India section success story would not have started. I now request Mr. Chris Ostrander to felicitate the mementos to the branch counselors. First is Dr. Swagata Sakar, Professor, Sri Sairam Engineering College, Chennai. Mr. V.S. Rajaraman, member, MTS section.
is the Vice Chair of MTS India section. I call upon Dr. Kanakaraj. Sir.
I request all the delegates to come off the dais to see the visuals of MTS India section.
December 2015 by visionary leaders Dr. R. Venkatesan and late Mr. K. Nanakumar. Our mission is to facilitate a broader understanding of marine technology's relevance to global challenges. Through knowledge sharing, research and education, we aim to drive technological progress in the marine industry. Following the guidelines of the parent organization, MTS India focuses on student engagement and professional collaboration. It serves as a hub for academia and industry to exchange knowledge, ideas, and breakthroughs in marine technology. Over the years, MTS India has expanded significantly, establishing 11 student sections in top universities and colleges across India. These include SRM Institute of Science and Technology, 2016, NIT Trichy, 2017, IIT Madras, 2019, Sri Sai Ram College of Engineering, Bangalore, 2019, AMET University, 2019, IIT Delhi, 2019, ZHCET AMU, 2020, Sri Sai Ram Engineering College, Chennai, 2022, Anna University, 2024. MTS India has been honored with several distinguished awards, celebrating its excellence in research, student engagement, and leadership. These accolades include Dr. R. Venkatesan received MTS Lockheed Martin Award 2017, MTS India Section received Outstanding Section Award in 2017, Dr. R. Venkatesan received MTS Fellow Recognition in 2019, MTS Undergraduate Scholarship 2017, 2018. 4 students, MTS Vemu Subramaniam Scholarship 2018, 2019. 4 students, Charles Busman UG Scholarship 2018, Outstanding Student Section Award globally to SRM Student Section in 2019. Ms. P. Nithishri received for attending MTS Summer Workshop in North Michigan College. Mr. Sridhar received Charles Busman UG Scholarship. Late Mr. K. Nandakumar received MTS Special Commendation Award. 2021, Dr. R. Venkatsan received C. Martech certification, a joint recognition of MTS and IMRS UK in 2021. Dr. Swagatha Sarkar received MTS Special Commendation Award. 2023, Dr. J. Preetha Roseland received MTS John P. Craven Award. 2022, Outstanding Student Section Award globally to Sri Sai Ram Engineering College, Bengaluru, 2022. The MTS Nanda Student Innovation Award is a tribute to our beloved late Mr. K. Nandakumar, founder and secretary of MTS India Section. To honor his vision, MTS India has established this prestigious annual award from the Corpus Fund, generated by donors and recognized by MTS HQ, to encourage and celebrate student innovation in marine technology. MTS India Section actively conducts a range of events including workshops, hands-on training, school outreach programs, MTS Techsurge, MTS TechSim, international conferences for providing a global platform for researchers, professionals, and students to discuss advancements in marine technology. MTS student members are actively engaged in cutting-edge research on underwater vehicles, autonomous underwater robotics, and marine exploration technologies, contributing to advancements in ocean science. So far, we completed 170 events. Join the Marine Technology Society today and become part of a community that's shaping the future of marine technology. Together, we can advance our understanding of the ocean and promote the development of new technologies and solutions that benefit society.
marks the 10th anniversary of MTS in SRM IST. We have a special message from our alumni for
Hi
Dr. J.
everyone, I'm Ajit Raj. Hi everyone, I'm Ajit Raj. I passed out of SRM in 2017 from Electrical Electronics. I currently work at Intel Bangalore. My journey with MTS began in a rather unexpected way. We as a group of students from SRM had gone to NIOT to meet Dr. Venkatesan sir to discuss about using their labs for a project we were working on at that time. During our discussion, Dr. Venkatesan recommended increasing the outreach of MTS by starting a student chapter to increase participation of students as well as foster research in this field. None of us had ever started a student chapter for any organization at that time, but we took up the challenge. The project that we were working on at that time was under a different department and not electrical electronics. So when we submitted the proposal to NIOT with Dr. Preeta Roslin as the chapter head, it surprised the original department so much that my friends were even questioning that why electrical electronics was chosen instead of their department, which was actually sponsoring the project as well. But all of us unanimously decided to go ahead with the formalization of chapter under Dr. Preeta Roslin ma'am, because everyone knew that we had made the right decision. And looking back, the success of that collaboration, whether it was the international awards and recognition for from India or the research project sponsorships that have come along, it all comes down to one person, Dr. Preeta Roslin ma'am. In nearly a decade of working in the corporate world, I still haven't met anyone who can process information, do research, maintain collaborations with different organizations, and still make sure that she has time for her students. It wasn't about just management of her schedule, it was also about just pure effort, pure energy being devoted to what she did, and it's something really rare that you see in today's world. She truly goes above and beyond every time, and I'm grateful to have been part of the legacy she built at SRM. Thank you.
Hi everyone, my name is Moinab. I pursued my PhD from Toronto University and I am currently about to begin postdoctoral research at Columbia University of Irvine. I joined the SRM MT student chapter early in 2018 and I had the privilege of being a part of it for about 3 years. Being a part of MTS played a very important role in guiding my academic journey. One of my most cherished moments from my time there was working together with the group to organize the grand MTS Chennai Section Project Expo. Those long hours of planning, coordination, and sometimes even laughing over small mistakes are memories that I always treasure. Lastly, I would like to express my deepest and most heartfelt gratitude to Preeta ma'am. She is the single most important person who has shaped my journey. She showered me with motherly love, guided me like her own child, and supported me both academically and emotionally. I am what I am because of her today, because of the constant belief in me that she had. She continues to guide me even today, and I truly believe that every achievement in my life carries her blessings. Thank you, ma'am, for everything that you have done for me and for all of us.
Hi everyone, I am Aryan and I have joined MTS Society in 2021 and I was been there in many positions till my graduation. And one of the beautiful memory I had was teaching juniors on how to use microcontrollers and also building a practical AUV for an IoT and also for my senior design project. And it has really shaped me as a practical engineer who can build anything and fly anything. Right now I work on drones, but this would have not have happened if Dr. Preeta Roslin would have not directed me to this channel where I can come to University of Texas Tyler and work here and build my career. I really thank Dr. Preeta Roslin and all other faculties to help me reach this goal. Thank you.
I know. Really good. This is Varsha. As of now, I'm married now, but I still feel very connected to my lab. I just wanted to share that after joining the lab, I learned a lot about hybrid microgrid and their controls. The lab gave me a lot of practical exposure, which really helped me understand the concept beyond theory. Working in lab also helped me develop my research thinking and problem solving. It is truly a great place for students. Personally, the hybrid microgrid project I worked there helped me build strong technical knowledge, and it also played a very important role to get my job. So I just wanted to thank you And thank you, ma'am, for giving me the opportunity and for your guidance. I'm really grateful for everything around there. Thank you.
We would now like to invite K. Vijay Kumar, Chairperson, School of Electrical Engineering, SRM, to give the vote of thanks.
Good morning, everyone. At the outset, I am extremely happy to propose the vote of thanks. First and foremost, I would like to express the sincere gratitude to MTS Society for giving us a permission to organize this MTS Techsurge 2026 Underwater Robotics at SRM Institute of Science and Technology. I am extremely grateful to express my sincere gratitude to Mr. Chris Osander, CEO of Marine Technology Society. So we were expecting you for the past 2 years. We are able to make you today because in spite of the various other global issues, we are able to make your presence today. Thank you, sir, for being with us today. I also express my sincere gratitude to Dr. A.S. Ivadanu Pillai, Chair Professor, SRM University. So thank you, sir. You are always a mentor to EEE department, especially to Preeta and to all of us for being with us today, sir, for making this presidential address. I also express my sincere gratitude to R. Venkatesan, sir, so the founder chair of MTS India section. If you want to say thanks to Venkatesan, sir, we cannot say in simple words. He is the one who is instrumental in starting this MTS chapter at SRM. So SRM is the first institute who started this MTS student chapter, and after that he was always a mentor to all of us and conducting many events. I think most of the events, I think 170 plus events are conducted in MTS chapter. Most of the events SRM will be hosting, I think. Thank you, sir, for being with us. Let us give a big round of applause to Venkatesan, sir. I also want to express my sincere gratitude to our Dean College of Engineering and Technology. He is always a mentor and guide for us. And also my sincere thanks to Dr. Napoleon, Dean Research. Sir, your presence today is really, inspiring for us. Sir was also helping us in collaborating with the NIOT in many ways for bringing us many projects to Preeta Rosalie. And also thank you, sir, for this opportunity. I also want to express a sincere thanks to the MTS India section chairperson, Dr. J. Preeta Rosalie. He was a faculty, he was started as a faculty mentor for SRM chapter, and he has now grown to the India section chair because of her hard work and dedication. Thank you, ma'am, for being with us and today, and also for making MTS India section to go at a higher level. I also want to express my sincere gratitude and thanks to all the delegates from various institutions and also the vice chair from MTS chapter and also the faculty members from various organizations. Last but not the least, I would like to thank the Department of Electrical and Electronics Engineering, especially the head of the department, Professor Sridhar, and other faculty members, and all the student members of MTS section for making this event happen. Thank you, one and all. I hope that this MTS search will be really a wonderful day, and you all carry a lot of memories with you this day. Thank you all. Thank you all.
Now I request Dr. R. Venkatesan to felicitate Dr. P. Kandaraj as Assistant MTS Branch Counselor. I request Dr. Chris to felicitate Dr. Kanagaraj as Assistant MTS Branch Counselor.
Full day needs.
I request Dr. R. Sundar from Amit and Mr. Chris Ostrander to felicitate our MTS India Section Branch Counselor.
Attendees, please stay seated as we take a quick photo with our delegates.
Poster participants, please go to your respective stands as the delegates will inaugurate the poster competition. We request the delegates to inaugurate the poster session outside the hall. After inauguration of posters, the participants are asked to have your tea break in the backside hall. The delegates are invited to the green room for refreshments. Thank you.
skills to navigate and excel in our field. And third, and finally, is to find a community and a professional home is essential. Being part of a supportive and engaged network can provide invaluable resources, connection opportunities, and support throughout your career. So I want to start with one of my favorite images. This is from a writer and blogger and stick figure illustrator named Tim Urban. When we think about our careers, when we think about our career paths, we tend to think they take a linear form, that you start at one point and you move sequentially through an ever-narrowing and predictable set of steps. But life and careers are anything but that. They are a constant choose-your-own-adventure with an ever-widening, not narrowing set of possibilities in front of you. When you make decisions in your career, you're not closing doors. You're opening new opportunities and you're opening new doors that will benefit you in the future. So as you consider your career path, it's helpful to understand the different sectors within ocean science and marine technology where you can apply your skills. Academia, that's an obvious one. We're at a university. Everyone here knows what academia is. It involves teaching, it involves research, and it involves training the next generation. Government also is pretty obvious. These are policymaking roles, regulatory affair roles, and public sector research. Private industry is one that most folks from universities don't go into. But these are businesses. This is where you develop and you build new technologies and services that push the industry forward. And the final space, the space where I work, the space where MTS lives every day, is in the non-governmental organization, the NGO, and nonprofit space. Some of these focus on conservation, some on advocacy, some on community outreach, and some, like MTS, on supporting this broad, growing ecosystem. The important thing I want to leave you with is that regardless of which of these sectors you choose to work in, your first choice doesn't lock you in forever. You have flexibility. So I want to share a little bit about my own career journey. When I was a student, I assumed that everybody else around me had their career figured out. I've learned now, 20 plus years later, that they didn't, and neither did I. Over the past 2 decades, my career has crossed through all 4 of those sectors we'll talk about today. I started in academia, I worked in government, in private industry, and now the nonprofit world. After I finished my undergraduate in 2003, I thought I knew exactly where I was headed. Like many students, and like my father before me, I assumed my entire career would stay within academia. But careers rarely follow the path you pick when you're 20 years old. I've transitioned roles nearly a dozen times, starting as an oceanographer, as a research technician, moving into program management, into a director role, a dean role, a vice president role, and now as CEO of MTS. Each move has brought new opportunities, new challenges, occasionally a few mistakes that taught me valuable lessons. What I didn't fully appreciate at the time was that each transition was building something transferable. Not just technical expertise, but judgment, relationships, and confidence. Looking back, my career has not been a straight line. It's been much more like a series of decisions made with very incomplete information. And so that's why I want to pause here for a moment. Because when you look at a timeline like this, it's very intentional. But it wasn't. And it certainly didn't feel that way when I was living in it. And there's a few moments along the way that shaped everything that came after. Moments when I wasn't sure what the right decision was, or whether something would succeed at all. So before we talk about the skills you need in your career and how to build them, I want to share some lessons. There's 4 things I've learned over my career that I wish someone would have told me earlier. Not as advice, because nobody when they're 20 is going to take advice, but as stories about decisions lessons that could have gone very differently if I hadn't made them. The first lesson is this: tackle problems that don't have obvious solutions. Just before graduating, finishing grad school, I realized finding an ocean technology job, especially one that would keep me in Hawaii where I'd gone to grad school, was harder than I thought. So a mentor offered me a risky opportunity. 1 year of funding, anybody here who's worked for a startup knows how terrifying that can be. 1 year, no guarantees. And I said yes. That program ultimately became the foundation of ocean observing across Hawaii and the U.S. Pacific Islands, and it's now the largest ocean observing system in the country. If it had failed, I still would have learned more in that year than in a safe job. Early in your career especially, growth often lives inside of uncertainty. And that's the time in your career to take calculated risks, because you still have many more years if something doesn't go the way you intended. The second lesson I want to leave you with is that every one of you is more prepared than you think you are. So a few years later, I was a young program director preparing for a major territories out by the Philippines. We had global CEOs and government leaders flying in from around the world to approve a multi-year strategy. My team spent over a year building. I was the director. I was pitching to my board of directors and my board chair. The night before the meeting, the board chair emailed me to say his flight was canceled from Manila and he wasn't going to make it at all. I was responsible for writing the entire meeting and chairing the board. I had 12 hours. I rewrote all my talking points to cover what I wanted him to say, and I asked and practiced answers to all the objections I figured the board was going to bring to me. And the next morning, I walked into that boardroom completely terrified. But the board trusted me. The meeting went smooth. The strategy was adopted. And that meeting showed me that I hadn't just built the skills to succeed. I actually had the confidence all along. You're going to find that opportunity arrives before you're ready. It's your job to take it. The third lesson: your ideas matter more than your title. Before I was at MTS, I was at the University of Utah, a big Research One university. And I noticed that different colleges were competing with each other for private foundation funding. That was frustrating donors, it was frustrating leadership, and so I had an idea. Why don't we create a centralized office where all of this can get done together? Not to control what people do, but to coordinate the strategy by which they do it. And I assumed at the time the idea might go nowhere. I pitched it to the president, who was my boss, and she approved it. She let us expand our team, we hired new people, and within a few years we had doubled our revenue over what it had been for the past decade. And I learned along that challenge that you don't have to wait to be the most senior person in the room to contribute something meaningful. If you see a better way forward, especially early in your career, say it and share your ideas. And the final lesson I want to leave you with may be the hardest one for me to learn. And it's that I want you to listen to yourself. So after this job at Utah, I moved into a commercialization role, managing patents and startup companies. My job was to spin companies out of the university and manage the university's entire intellectual property portfolio. The compensation was the best I had ever made anywhere in my career. It was really, really good money. But the leadership environment, the vice president I worked for, was toxic. I wasn't sleeping, my team was burned out, people around me were quitting. I was the third director in 3 years. And I knew I wasn't equipped to succeed given those conditions. So despite the money and despite the title, I quit. I walked away. I had no backup plan. I had no next job. I had a young family at home to support, and I was completely terrified. That was a hard decision. And it was one of the best decisions I had ever made. Because sometimes courage isn't about choosing the next opportunity. Sometimes it's walking away from the wrong one so that you have that ability. I learned in that moment that if something feels wrong, it probably is. And you don't need to know what comes next before you choose a better direction. Remember that careers in marine technology, or any field, are rarely linear. They're built through risk, through community, through learning, and through courage. And across all of those moments in my career, across all the sectors I've worked in, certain skills kept showing up again and again. Certain keys to success: leadership, communication, strategy, partnerships. So let's talk about the core competencies that help you navigate moments like the ones I've shared, regardless of the path you choose. So no matter what sector you work in, whether you're a professor, whether you run a startup, whether you work for the government or you work for an organization like MTS, certain core skills and competencies are always essential in this field. And they include leadership, data analysis, fundraising, being able to ask for money, being able to set a vision and form a strategy, and then translate that strategy into action, to manage change, to manage assessment, to implement, and most importantly, to be able to write, and write persuasively. Developing and honing these skills will not only make you more effective in your current role, but provides you the flexibility to transition across different sectors and tackle a wide array of challenges throughout your career. So let's discuss some practical strategies. How do you build? How do you strengthen these skills? The first thing I would leave you with is to say yes to every opportunity that comes your way. Early in your career, I want you to embrace as many experiences as possible. Your job is to become the most interesting person with the richest set of lived experience of anyone you know. Whether it's joining a research cruise, writing a paper, shadowing a colleague, traveling to a workshop, every opportunity you say yes to broadens your horizons, and it builds valuable experience. The trick here is not to say yes to everything that someone asks you to do. That will take all of your time. But say yes to anything that gives you a new experience, that teaches you something that you can then use to relate to someone else. The second piece I would suggest is that you learn to be okay being told no. Throughout your career, you're going to ask for a lot of things. You're going to ask for raises. You're going to ask for promotions. You're going to ask for grants. You're going to ask for opportunity. And rejection is part of the process. Don't let no deter you. Instead, I want you to view every time you hear no as a stepping stone, a learning experience, and a reminder to keep advocating for yourself and for your ideas. Asking and advocating takes practice. You don't get to yes every time. I started my career as a fundraiser, somebody who asks for money. The best fundraisers in the business are told no 75% of the time. 25% is a good rate of yes. You have to ask, and you have to be okay being told no. When I was young, my father told me, if you don't ask for what you want, you're only ever going to get what someone else thinks you're worth. If you don't ask, you can't have it. The third is to dream big and accept the risk that comes with it. So Ellen Johnson Sirleaf was the first female president in Africa, and she was the president of Liberia when she won the Nobel Peace Prize. In her memoir, she penned the phrase, "If your dreams don't scare you, they aren't big enough." And I find this to be a poignant reminder that you should set ambitious goals that excite you and that challenge you. If your goals are safe, if your goals are easy, then everyone else will likely achieve them before you do. Achieving big dreams often involves taking calculated risk and stepping outside of your comfort zone. The fourth point, I know every student here doesn't want to hear this because you're looking forward to graduating, but always be a student. Not literally, don't always stay in school, but always be learning. Commit to lifelong learning. Stay curious, seek knowledge beyond your immediate field, and stay informed about global developments. Because continuous learning, like lived experience, keeps you adaptable, it keeps you innovative, and it helps you relate to people that aren't inside your normal sphere. The fifth way you can build these skills is to write, and write a lot. Effective writing is a powerful and probably the most underappreciated skill in marine technology. Practice regularly to improve your clarity and your persuasion in how you communicate. This is essential no matter what sector you work in. Despite the ease of generative AI, despite Claude and Gemini and ChatGPT, which can write your notes and write papers and write talks, understanding at an individual level how to shape words together, the wisdom of communication, cannot and will never be done by machines. It can only be done by you. And the last piece is to find and tap into a community. So engage with a professional network that shares your interests, that shares your values, because careers rarely advance alone. Communities like MTS and others provide membership, they provide perspective and mentorship, and they often provide unexpected opportunity. So a few months ago at an MTS event, I was visiting colleagues in Hawaii, and I reached out to someone in my network just to strengthen our relationship and sit down for dinner. And over dinner, we discovered a very small world connection to one of my National Science Foundation program officers. My program officer was her mother. So we took a picture, we sent her a selfie from dinner, and we just agreed we'd stay in touch. A short time later, my program officer reached out and invited her. One dinner, one connection, $100,000 in new funding. Opportunities don't always come along or only come along from formal meetings or job applications. Oftentimes they come from relationships you've invested in over a long time. So implementing these 6 strategies will not only develop your skills and make you better at the job you have, it will also enhance your resilience and your adaptability and your readiness to seize opportunities as they arise. So let me close by highlighting a few very real opportunities for students, for early career professionals, and for entrepreneurs in the room. First, the MTS India section and emerging student sections around the country are becoming important hubs of activity. These groups connect students with professionals, they host technical talks and meetings like this, and they create local entry points into the global ocean technology community. The second, MTS is investing heavily in workforce development for the ocean enterprise around the world. That includes technical workshops, micro-credentials, internships, and partnerships with universities designed to help students move from the classroom into real engineering and research roles. The third, We run programs that help people enter the field early. The MATE ROV competition develops hands-on engineering skills for thousands of students around the world every year. And the Ocean Exchange Collegiate Awards recognize innovative ideas from student founders and early stage teams. Those who win those collegiate awards receive $10,000 with no questions asked. And fourth, for those of you interested in entrepreneurship, MTS supports ocean technology startups through Ocean Exchange, which provides $100,000 of non-dilutive funding, mentorship, and access to investors and industry partners for companies anywhere in the world. All of these programs are designed to help talented people like you move from interest to real participation in the ocean technology enterprise. And so I'll end with a special invitation for all the students in the room today. In addition to the programs I just mentioned, MTS offers several very tangible opportunities specifically for students and graduate researchers. First, we offer scholarships, travel grants, and awards that support students engaged in meaningful work in marine and ocean tech. Applications for this year's MTS scholarships are open now, and they close next week on March 23rd. Second, programs like Emerge and the MTS Career Accelerator help early career professionals and students build leadership skills, understand industry pathways, and develop strong networks. Applications for this year's Emerge program are open through April 17th, and the Career Accelerator webinars are free for anyone who is an active MTS member. The third, student sections are one of the most powerful ways to build community locally. MTS provides $500 in annual support for every student section. You simply need to ask and organize. And finally, through Ocean Exchange, we offer $10,000 to students as non-dilutive funding for promising student-led innovations and startup ideas that can turn into a company. You can have an idea. We can help you turn that idea into something tangible. And these are opportunities that you can begin engaging with today, right now. Thanks to the leadership of the India section, we're also pleased to offer a special discounted student membership rate for students in India. When you join through the MTS website and select student membership, use the code on the screen, India Student, and your annual dues are $10 instead of the usual $25. Join your local student section, connect with the India section, and start building relationships within the global ocean technology community. So, I want to thank all of you for spending time with me today, and with all of us today, and for listening. The career paths before you are diverse, and they're often unpredictable. What matters most is building your skills, embracing opportunities when they appear, and surrounding yourself with communities that support your growth. The ocean challenges we face are global, but the solutions will always be connected to engineers, to scientists, and to entrepreneurs who understand their own coastlines, their communities, and their local priorities. That's why the work happening here in Chennai matters far more than just within India. I'm excited to see the technologies, the companies, and the ideas that will emerge from this community in the years ahead. And I hope many of you will choose to be part of that journey with MTS. Thank you very much.
Thank you, Mr. Ostrander, for that inspirational speech. Now, I would like to call up Dr. Salim Anwar Khan, professor from Algar Muslim University, to receive a memento from Mr. Chris Ostrander. Now, I would like to invite the second keynote. I would like to invite the second keynote session. This is going to be hosted by Dr. A. Shivadhanu Pillai. I'd like to call up Dr. C. Nitya to introduce Dr. A. Shivadhanu Pillai.
Dr. E. Shivadhanu Pillai is a renowned Indian defense scientist and technologist, best known as founder, CEO, and managing director of BrahMos Aerospace, the joint venture between India and Russia that developed one of the world's fastest supersonic cruise missile. He played a pivotal role in transforming the BrahMos project into a successful strategic defense program for India. Dr. Pillai worked for several decades with Defense Research and Development Organization, where he contributed significantly to advanced missile and aerospace technologies. He is currently closely collaborated with former President APJ Abdul Kalam during India's Integrated Guided Missile Development Program. In recognition of his contribution to India's defense and technology sector, Dr. Pillai has received numerous honors, including Padma Shri, one of India's highest civil. He is known for promoting innovation, strategy, technology, partnership, and indigenous defense developments. We welcome you, sir.
Let's see. Good morning. So I thought that my talk will be in the marine technology, which is everybody clear? Huh? Is it okay? So the marine technology is relevant to your today's MTS Techsurge 26. Yeah. Okay. I'm a defense man, so I'll be talking more on the defense side. See, the war strategies are changing. Earlier it was human-centric, and so many things came, and underwater, and then now it is intelligent and autonomous systems, all network-centric with AI and IoT playing a very important role. Space-based systems have come, similarly underwater systems have come, underwater weapons, platforms, and also robotics. So ocean dominance is one of the important requirements for the future war. So the war is, the battlefield is now is a high technology warfare, or supersonic, hypersonic, cruise missiles, anti-missile defenses, drones, underwater command systems, beamed energy weapons, space-based weapons, all the crowded, the geo-orbits, the space is crowded, underwater is also becoming very important, and war in cyberspace. If you look at it, the whole new paradigm is the multi-strength is determined by the effective intelligence, surveillance, rapid response to threat, precision strike, intelligence systems, effectiveness, and force. The whole things are changing, and where the unmanned systems or underwater unmanned systems are playing very important role in the whole field. So what we are trying to do is that we are trying to see it is totally network-centric, and the intelligence is done by the robotic systems in underwater, command, control, communication, computer, a very important role which is linked to platforms, smart sensors, with the AI IoT and after the precision data robotics. The whole thing is centric, network. And if you see the evolution of many things, how what we talk about the robotics have come, and all the waves, inventions, innovations. There are waves. First wave was in 1785 to 1845 when the cotton, iron, water power came. Then second wave, mechanization. Third wave is electricity. Fourth wave is electronics, aerospace. And the fifth wave was software, digital network, mobility, media. But the number of years is shrinking over the period of the waves. So since 2020, we are now in the new creative destruction, is the sixth wave. And the sixth wave is dominated by generative AI, robots, nanotechnology, sustainability, network systems, autonomous, hypersonic, photonics, laser, and all leading to algorithmic situation, intelligence with quantum computing, finally leading to new biological systems in genetic engineering, including gene, gene dating, and so many new things are coming in the genome. Then renewable energy, space resources, how to utilize space, to bring resources from planets and then leading to brain and quantum transportation, robotic systems. So in marine technology also many things are happening. Sonars, ship, submarine and helicopter. Then hydrodynamic testing, test systems, stealth technology, underwater weapons like torpedoes, mines, hybrid systems, and countermeasure systems like the advanced torpedo defense and with the decoys, and flatfish heavyweight AUVs and high endurance sails, all coming up marine technology. And you see that the core competence of defense DRDO today in India, we have developed all the sonar systems, and these are connected in our ships and submarines. We have totally it is indigenous system in ships and submarine, and also in the heli-mode. And all the technologies relevant to that, like transducers, signal conditioning, processing, display, all oceanographic systems, all have been developed, materials developed in India. And these are the space is the unmounted sonars, towing sonars, and this is the dunking sonar, all have been developed. So really we have got the technologies available today, transducer technology in the bigger one to the MEM side, and also electronic systems, all operating systems. And the airborne winch for the helicopter, then dunking for sonar, the dunk bodies, transmitters, electro-mechanical connectors, network array, all these things are available. And in the submarine, we have got the complete, the total submarine is crowded with number of sensors, like the forward sensor, which is different to identify the enemy submarine movement. Then flank array sonar, operating consoles inside, then road array sonar, all these facility technology available. So communication is very important, underwater communication developments are targeted. Now these are the proposed development which the SRM and other universities can think of doing. So I thought I would just highlight you the memo and SMO enhanced underwater communication by using multiple transducers, receivers, combat detonation, multiple load finding, and low finding. So developments targeted point-to-point memo communication. So the multiple input and multiple output. That's really single input and multiple output communication systems. So this is one opportunity for development. Similarly, another development is power transmission in underwater. This is another area where work is being done. This is currently which has been developed is not very efficient. So we are looking for more efficient systems. And acoustic modems development and swarm of mobile acoustic nodes. On the local side, the torpedoes, the light alloy torpedoes that we call it advanced lightweight torpedo is what you see here. The small torpedo, launched from ship as well as submarine. Similarly, the heavyweight torpedoes like the Varnastra, and then we have thermal torpedo, and we are now working on supersonic torpedo in underwater. Like that, many developments are happening in India. And for submarine, for diesel submarines, to remain in water for a long time, we have developed the air independent propulsion. So also we have the ocean sats to look at the ocean from space. We have got the satellite systems totally dedicated for the Indian naval operations and also for the marine movement. And also the torpedo, these drones have come to now light even launched from ships to do the survey around. So we have got one of the very important satellites we have got called NASA ISRO Cylindric Aperture Radar, which is also monitoring, it is going around. It takes for one orbit and 14 orbits per day. And even 1 centimeter variation in the land it can do, and also it is monitoring the ocean and all the ship movements, even the submarine movements are all being looked at from the satellite. This is one of the things for we even know from space we can monitor the satellite. And in the drones for development, there are many new things are coming up. One is a startup in India, in Bangalore, called they have developed a very nice system. Air and water. Same system is used. So Aqua AirX is the company, the startup company, startup, which has come out with a very good idea for air and water operation for the same system called Amazon. So the new sensors which are being developed by DRDO is underwater system, underwater drone, with the advanced sensors and the cameras. You can see that these are the systems which are coming up now. And new types of propellers and other systems are also developed. So with the underwater drones, they gather critical intelligence in high risk coastal areas, map underwater terrains, and also assist in monitoring. And then a dual mode maritime underwater vehicle goes underwater as well as in surface. When it's surface, it projects the antenna and completely monitors around, and it closes it and then goes down the water. So for defense, security, and also cyber security systems are being used. So the world now is more worried about the industry development. We are now moving to the cyber physical systems which are there now, and developing many things like autonomous robots, big data, augmented reality, additive manufacturing, cyber security, industry, industrial these are the building blocks for the industry 4.0, but now we are moving to industry 5.0, which will be generative AI added and also sustainability maintained and the human centric. So three components are there: sustainability, resilience, and human centric. This is the five more, which is where the systems are going to be more AI oriented and the autonomous systems more robo as underwater robot as well as the AI playing a very important role for the pipeline. So when you talk about robo, you see underwater robots. So these are the new emerging robots which are going to come. These are as well as the space. The space robo, you see that these are underwater robots. And the humanoids coming up for underwater operations. And so the robotic systems are playing very important role. So underwater robotics, when we talk about the safety for human divers, oil and gas industry, particularly when they have laid a lot of pipelines underwater, so there is a requirement for unmanned underwater robot. Then defense, surveillance, mine detection. You know that recently the mines are playing a very important role in the Iran war. Environmental protection and marine conservation, acquisition, data collection, and particularly in underwater disaster recovery and salvage operations, advancements in communication and navigation in underwater acoustic signals, fiber optic, surface-based relay systems. So now there is a big thing going on how to use RF systems in underwater. New development going on and cost effective. So the underwater robotics play a very important role, and that's why the organizers discuss on underwater robotic systems. So future of underwater robotics, if you see that the AI coming up, so AI integration with robots, they will become more autonomous and it will be capable of self-learning and adaptive decision making. So it will give a modular design, upgraded power and imaging systems, multi-load capabilities and AI power features, then longer battery life and wireless charging, and it's possible with the there's a new innovation coming up, wireless charging underwater, and this energy storage will allow robots to take larger missions without frequently charging. Then bio-inspired robotics is inspired by the marine life, and vector sensors and imaging technology includes sonars, and also the imaging tools to provide clearer water visuals and mapping and research. So these are the future of the robotic systems coming up. And the AI is also moving up in big ways. Moving to now the agentic AI has come now. It's now from generative AI we are moving to agentic AI, which is going to be a big revolution happening. Just started, and finally it will be ASI. That is, the we want to completely make it human power. So that's what is the attempt to give the brain power to the full brain power to the AI. So this AI is very important for your road systems, for sustainability and intelligent automation. So agentic AI will fall from assistance to autonomy, green computing, and green computing, AGI, and quantum systems will transform the industries, and also it will be available for the robotics. They will reshape the work design, and also the new careers will emerge. The AI, we just now discussed about the career path for the people. Great talked about it. So the new careers emerging in AI, cybersecurity, and sustainability. So you have got a great future in front of you. So agentic AI is going to be very important if that's compared to the traditional AI. It is going to be very the main thing is autonomy and adaptive and self improvement, self-maintaining. So that's going to be very important. So the quantum also coming up. The quantum also, there's a big thing happening. Fiber optic secure quantum network. This is also underwater network for fiber optics. Actually, underwater sensing, sea mapping, the quantum sensing. This is new parts SRM, we have taken up the quantum development using photonics, big wave. IoT, then the IoT in underwater. So, Internet of underwater technology, underwater is going to come. Internet of Things. Here it is called Internet of Underwater Things. There's a new architecture coming up. This is for sensing and communication entries. We call sensor nodes. So endpoint nodes are devices including sensors, cameras, microphones, actuators, and radio acoustic. This is the endpoint. And the mid-layer nodes will have the modems, gateways, repeaters, lanes, and sync nodes will be located on buoys, ships, and satellites on the platforms. So this is going to be the new thing which is coming up for integrated systems. Integrated systems which are going to come in the underwater technology. So the new network is coming up, and there are a number of robotic systems are coming up which will enable the Internet of application of IoT is aquaculture, water quality monitoring, pipeline monitoring, and the aquatic animal tracking, seaport monitoring, things of tsunami prediction, smart ocean monitoring. So NIoT, some are there from NIoT here. So NIoT has taken up in a big way in the and they are having a major program now. The Director Innovative has announced, unfortunately it did not come today, a scientific human submersible which can take 3 human beings to 6 kilometer depth. This vehicle is called Matsya 6000 and the mission is called Samudra. It's a very important program for India today. It's a major breakthrough we are going to achieve by sending the human 6 kilometers down. So NIoT is working on that program, which is a very, very important program in the deep sea. So ocean also is providing you energy generation. It's one of the things which we have to see that because you see that the ocean energy, if you look at it, the 70% of the earth is ocean, and it is a solar collector. 250 billion barrels of oil each day it collects, equivalent. So it is energy absorbing, very big energy absorbing thing is the ocean. So what happens? We are not using that energy. So people try to use the tidal waves and also the currents and also the thermal difference. So people are trying to develop systems which can enable generating the energy. These are the clean energy things. As well as one important thing you have found out, that uranium. So uranium in underwater, in this ocean, 4 billion tons of uranium seawater would fuel 1,000 numbers of 1,000 megawatt nuclear plants. For 100,000 years, energy can generate. That much uranium is also available at the moment. So there's a lot of things which need to be spent on the coordinated generation. So where the robotics will also be used, so you can create islands in the ocean, then have the wind energy as well as the solar energy pumped into that from satellites, solar power satellites, and also you can have the water purification. So many things can be done in underwater, and with the formation of small islands like this. So that's one of the very important concepts which has come up for energy conversion. So one more thing is that we are worried about the nuclear plants on the land. We have small nuclear floating plants now we have seen, and also there is totally operated autonomous operation. The robotic technology can be done. So weapon side also very important developments are happening. We have got the submarine launched ballistic missiles and long range missiles we have in India. Similarly, we have got a supersonic cruise missile on the sea. It can be inclined launches, vertical launches from sea and underwater. This one is one of the best systems. The leader in the world leader in the India dominates today in the development of supersonic cruise missiles. And how we have got the system inducted in the Navy, as well as we have got the systems for underwater systems. So in all round the energy and robotic systems, different type, as well as different sensors, all have been developed in India. So India is one of the lead countries in terms of technology. There are a lot of future for the robotic systems. I hope that in the presentations we will be discussing the various techniques as well as technology for the future of robotic systems. Thank you.
Our next keynote session is by Dr. V. Balanagajyoti, scientist of NIOD. I call upon Dr. Vasant to introduce Dr. V. Balanagajyoti.
Dr. V. Balanagajyoti is a scientist at National Institute of Ocean Technology, Chennai, which operates under Indian Ministry of Earth Sciences. Her research primarily focuses on underwater robotics, autonomous navigation systems, autonomous underwater vehicles, and marine technology applications. She has extensively contributed to development of AI and machine learning based navigation and domain, as well as guiding systems for the underwater vehicles, which helped in improving the autonomy as well as the efficiency of subsea exploration. And her work supports on applications such as deep sea exploration and ocean observation, marine resource assessment, and underwater robotic systems. Dr. Jyoti has authored more than 30 plus scientific publications in the area of underwater robotics, navigation, electromagnetic homing and guidance for AUVs, machine learning based ocean current profiling and prediction, deep sea vehicle systems, etc. She has also been recognized with the Outstanding Women Researcher Award in Underwater Robotics, acknowledging her contributions to advanced marine technology and underwater robotic systems. We welcome you, ma'am. Thank you.
Thank you so much, Vasant, for introducing me, and thanks for Preetham for giving this opportunity to present on underwater robotics. Actually, Shivdana Pallai sir has explained everything, underwater, defense, naval application, and aerospace, all the applications. But now I am going to present guidance and navigation and communication systems for strategic underwater robotics. Next slide. So NIOT now, Dr. Yudhana Pillai sir was telling, we are under from Ministry of Earth Sciences. Almost like 10 institutes are there. In that, the National Institute of Ocean Technology is one of the department where the underwater vehicles, tsunami early warning systems, all the technologies are developed for Indian Ocean. Next. So NIOT is having so many departments. We are working for meeting the United Nations Sustainable Development Goals, like food and technology, then surveillance, then coastal and resilience. Like these different applications are there. And we are from Deep Sea Technologies, where the deep water remotely operated vehicles, unmanned and manned vehicles are developed. So I think everyone heard of deep ocean mission, Samudriyan mission. I just want to make this session little interactive. How many people knows about Matsya 6000 vehicle? Good, at least. Okay. So this is a 3 crew member vehicle where we will be going up to 6,000 meter depth in Indian Ocean potential sites like Central Indian Ocean Basin to explore the minerals and all. Next. So today I am going to present what are the different types of underwater vehicles where guidance, navigation and control is very important and challenging. It is not like terrestrial vehicle like drone or other satellites. So how this GNC realization is challenging. So how we are developing for our deep water AEV, and Sir was also telling about bio-inspired robotics. So this is one more project I am doing, bio-inspired homing and docking systems. And for digital twin development, Preeta Madam's project, she has done under a deep ocean mission. A digital twin system she has developed for Matsya 6000. Here we will be estimating the position of the Matsya during off-nominal scenarios. So next, how the virtual simulation software required for simulating the underwater environment and different off-nominal scenarios. This also I will be explaining. Next. So why we have to develop first of all underwater vehicles? What is the mandate? What is the need? So we have potential sites in our Indian Ocean. So this southern Indian Ocean where we get different ridges are there. Rodriguez Triple Junction. This is hydrothermal vent potential area where the sulfide volcanoes will be there. So the temperature, if you see there, it will be around 400 to 500 degrees Celsius. But the marine creatures are surviving in that near the sulfide volcanoes and outside. Outside it will be around 3 degrees, 3 to 4 degrees. How these cultures are surviving different temperatures. Next is CAOB basin. Here manganese nodules. It is a potential rich of minerals where lakhs of square kilometers are these minerals are spread over. Because due to tectonic plate movements and geophysics, like physics, temperature and pressure, these all nodules are formed. And then gas hydrates. These are all the like fossils, carbon fuels are available in Krishna Godavari basin. So like this we got different potential sites where we have to explore and we have to get the expedition and results, and then inspection also. Any missing aircraft are there. So we have to work there also. If you see Malaysian Airlines in 2015, one aircraft was missing. So till now they have not identified it. Okay. Even though the technology is being developed a lot in the world, but still challenges are there. Ocean is not like space or ground. It is very, very challenging. Next. So we have different disciplines where we are working for the sustainable development goals. Green shipping, we are having vessel management cells, where we have different ships to go for until Antarctica and Arctic.
and carbon resilience, this climate change we are working on, and ocean monitoring like tsunami warning systems, and marine biotechnology for food. And then like this different non-renewable and renewable resources we are working, and these are all the different vehicles developed in our group. And we have been working for the next 2026 to 2036. We are working on the autonomous vehicles and human occupied vehicles also. This looks very challenging and hypothesis, but I think we can realize it. Next. So when you come, it is a remotely different types of vehicles. Remotely operated vehicle with the power is unlimited, because it will be operated from the ship and pilot will be operating from the mothership. And then comes to an autonomous underwater vehicle, it is a battery operated, but so it is limited in its operation. Human occupied vehicle for intervention and all, it will be very useful. So coming to this type of vehicles. So here guidance. What is the guidance? Can anyone give a small definition? In layman words also is okay. So here MTS, the person also was telling how he was guided to become from fundraiser to manager. So like that, where to go, which is the potential site, how you want to survey, that is a guidance. Whether this is a lawnmower trajectory or what is just a rectangular survey or a circular path like that. So that is a guidance. So path planning will be done in the mission planning, and then navigation systems. In previous presentation also he was saying whether we can go for MEMS based inertial sensors or fiber optic gyro based sensors. How precisely you have to go to the location and get the data. And then control. See, maneuvering. How you are steering your car when you are going from one place to other place, like that. If navigation is good, your control also will be the best. Then to the vehicle, then all the sensors, sensing the environment, perceiving the environment is very important. Next. So here, this is the control architecture of AUV. Because for ROV it is not much there, because the pilot always seeing the feedback from the cameras and other environmental sensors like sonar. He will be taking the decision and he will be controlling the vehicle. When it comes to autonomy, autonomy is very important. Intelligence to the vehicle should be built by us, taking the all these different subsystems. So navigation environment, whether we are going in a safe environment, so sea states and all we have to see. And particular location where we have to go on research. Then the guidance. Those different guidance techniques are there. Waypoint guidance, which is in the line of sight. For that, when you go in the waypoint guidance, the heading control is very important. So we have to head it properly. Then we will be giving the control to AE. So like this is the heading controller in XY plane and depth controller is Z axis. How much deep you have to go? You have to go for 5,000 meter, you cannot go to 6,000 meter and do research. So that is depth control. So starting point to destination point, path planning we have to do. Then horizontal line of sight and vertical line of sight we have to do. So these and all involve translational and rotational movements to make the GNC system precise for the vehicle. So different guidance techniques I have given here. Line of sight guidance, pure pursuit, then vector feed. Now if you see many drones and all, people are making GSLV vehicle for the recent last Dasara event and all. So how that drone swarm techniques and all formed, that is through vector field and potential field guidance only. So this everything we can implement, but everything is having advantages and limitations. So when you see the next graph, here sway velocity and set velocity, these are the XY planes where we have to control when we go from one point to another point. What is the acceptance zone? So here the Kalman filters, like unsupervised and supervised filters will be coming into play. And guidance is over, now position estimation. So how your dead reckoning is done. When I travel in this direction straight line, with the taking the heading and how much distance to be traveled, we have to calculate and how much time to need. So the velocity of the vehicle also to be tuned. Next.
So in underwater navigation, as Shivadhan Pillai sir was telling, we will be using fiber optic gyro-based INS, inertial navigation system, where the vehicle will be first initialized with the GPS. After later that, it will be aided with acoustic positioning system that is called as underwater GPS, and then depth sensor will be the Z-axis parameter, and DVL will be aiding as a odometer. So these all the aiding sensors will give the position of the current position of the vehicle when you go in a survey. So this is the navigation algorithm where it will be working in the inertial navigation system. So inertial navigation system will be consisting of accelerometers and gyroscopes, where we will be getting the rotational and translation motion, and then we will be estimating using dead reckoning principle the next position of the vehicle. Next. So this is acoustic positioning system. So in underwater, I think everyone knows that RF signals cannot propagate. So we have to depend on the acoustic signals only acoustic propagation. So but it is having different challenges because of the sound velocity profile medium. It is different in Bay of Bengal, it is different in Arabian Sea, like that. So here the seabed transport result, that is nothing but mounted on the vehicle. So we will be computing the azimuth and bearing angle related with the ship. So now I am here, but we are calculating our position using GPS satellites. But in underwater it is not so. Maximum 12 kilometer range only we can estimate the position. So that all challenges are there. Next. So I was telling we have autonomous underwater vehicle. Actually one AN32, one flight was missing in 2018. We have gone with ROV, but we could not find the location of any missing parts of the AN32. But later we had our this deep water AAV vehicle developed. Then we have done the synthetic aperture sonar survey. First initially they gave one location, but when all the debris of the AN32 flight has gone away 10 kilometers away from the given location. So remotely operated vehicle has limitation, only 300 meter range you can survey. But autonomous underwater vehicle we can make almost like 25 kilometers by 25 kilometers survey. So this is the advantage of the AV over ROV. So we have gone to that location around 275 kilometers from Chennai. So this is the path planning we have defined to the vehicle. So if you see, almost we have done 4 kilometers by 4 kilometers survey, and where we can go up to very near and we can take the color visuals. Next. So this is the real time. This is the red line and white line. These are all from the vehicle with acoustic positioning system. These are all the real-time data we are getting. This in the back side is vehicle parameters, health status we will be getting. And the down is the depth profile, AUV showing. So we have gone to that location at 3,400 meter depth. We got the debris of the AN32. You can imagine going to 3,400 meters means what will be the challenge? Anyone? Pressure is almost 340 bar pressure will be there. So we have to depend on underwater robotics only. Next. So this is one more project, bio-inspired autonomous homing and docking. So now AEV can go for 48 hours operation, but I want to go for 100 hours. Then we have to increase the endurance by charging and discharging of the battery. We can increase the endurance. So we are having now so many EV based vehicles, right? So we are having all the charging ports every 10 kilometers or every 5 kilometers. So like that, we are planning to have a submerged docking station to recharge the batteries of the AEVs and go for the next operation. So when it is very long range, like 2 kilometers away from the docking station, AEV will take the acoustic support, and then coming to 35 meters, it will take the sonar or acoustic sensors. And then coming to 15 meters, we can go for electromagnetic guidance, and close distance, which it is like a vision. So this is one of the challenge I am working with. Next. So for the short guidance, we have developed a deep learned AI-based system. We are using YOLO-based algorithms, and for the electromagnetic and vision-based, I have done all this work, and it is a very promising with the latest AI/ML-based techniques. Next. So this is one more application we have developed for MTS 6000. So the position when during off-nominal scenarios, during failure of all the sensors, where the MTS will be surfaced. So this also we have trained with the AML data of the sea current, and then estimating the position using the dead reckoning algorithm has been done. Next. So this is one more now upcoming vehicle. This is actually Gazebo software. It is a 3D physics based simulator which allows us to design and testing and of all the underwater vehicles in the world. So now I am going to develop one AEB for 6000 meter. But before that, we want to understand the design, hydrodynamic analysis, and all we have to study with the mathematical how it is going to behave. Then before production, I can correct all the design parameters and whatever I have defined, whether it is working or not. So these and all we can select. And we can model the ocean currents, and we can model what are the sensors type from low assessment based to FOG based, and this one we can work on the autonomous navigation also. This is working on the ROS platform. Sorry, actually they have copied. And this is the we are having Ardu pilot. It is a open source. We for our customized underwater sensors, this we cannot use. So we are developing our own GNC, and this one we have tested, and I just wanted to show the video because machine guidance, navigation, and control algorithms is a very complex for underwater vehicles. It is not like a ready-made available and we can use it. Can you play that video? Video. Be operated in manual and autonomous mode, and we will be predefining the path, and then the AAV will know the exact location, and during any off-nominal, the ASV, the surface vehicle will come into return to home. This is the launch of the Manas. Manas means it is intelligence developed. So everyone will be having the Manas action. So this is the path following by Manas and position tracking and data visualization. So here will be, this is the surface console and this is real-time trajectory, how it is following. So the heading control AHRS data is taken for the heading control. and from the GPS we are calculating the how much distance to be traveled and which direction and all. So this is the first work we have completed. The same we will be porting into autonomous underwater vehicle. So this is the RSPS I was telling that. So here before deployment of your logics and all, or before finalizing your manufacturing design, we can test all the algorithm, hydrodynamic parameters, all the design parameters of the AAV, and we can take a decision. Here we have developed obstacle detection and avoidance algorithm. So the AAV will be having the sonar, and it will be detecting the developed, and now we are testing in this gazebo simulation environment. So this is the obstacle actually, so it will be taking the turn. So the turning radius, how much we can define the turning radius, and the vehicle should not go and hit the obstacle. So that the brown color one is the obstacle, and how your vehicle is taking a turn in the real time, how it is taking the decision and all. We can visualize and we can modify the algorithm. What sensor I can go for, like this, and everything we can simulate in this environment and do the vehicle before deployment in open sea environment. This will be the best methodology to go ahead. Any questions?
Yeah, I have a question. Like, what kind of new technologies and AI you think like can incorporate in your underwater systems?
That's what actually now different based on the application. Now if I'm going to coral site, then your vision should be very good. Vision algorithms like YOLO, detecting the coral and we should not destroy the environment. So based on that coral detection or object detection, your vehicle should be controlled. So like that, so unsupervised, supervised algorithms. Now many things are coming. CNN, then YOLO. Like these deep learning algorithms will be very much required. Now we are going for that obstacle detection using sonar data. So then also AI deep learning based algorithms will be very useful. That's what we are now trying by embedding all the latest technologies.
It is very good presentation actually. With respect to the homing and docking stations, what is the depth of this docking station will be there normally, and what is the preferred source for this power source, which we are planning to do?
Actually, our homing docking station also we are doing wireless power transfer. So now docking station we are planning for 50-meter depth installation, because in deeper water again installation challenges will be there. So the docking station will be kept at 30 to 50-meter water depth. We are planning it will be powered by solar buoy, because from surface to 30 meter to go also it will be challenging. At least I think we have to travel for 30 meter, we have to travel at least 2-3 kilometers from the seashore. So we have to run a cable to queue. So we are planning to have a buoy with solar power.
Anybody else who wants to ask?
Good morning, ma'am.
Yeah.
In this, how will be the coordinates of the docking system? Means what will be the coordinates of where to dock the water?
That is a very challenging question. Coming to home, so that's why we will be depending on the acoustics. acoustic positioning system will be guiding the AEV to reach the docking station, and then we will be going for sonar aid, and then electromagnetic and visual. And the boat will be knowing the location of the docking station. Like depth we will be knowing, 30-meter depth. And where we are installing also, the lateral position will be known to the boat. Okay.
Good afternoon, ma'am. I think it will be more costly. Are there any alternative ways, like we can use waypoints?
Yes, waypoint guidance only will be given. So when the boat complete the survey work, then it has to come to the docking station for charging its battery, right? So complete all survey will be the waypoint. But coming to homing and docking to the docking station will be a very challenging process. So we should have acoustics aided with other guidance techniques. So we are working on the electromagnetic. If water is very turbid, then your vision cannot work properly. We have to depend on acoustics or electromagnetic. As I told, the electromagnetic will have the attenuation, more attenuation. Then we will be depending on the vision or acoustics again. So electromagnetic will be operating in a very low frequency where the attenuation is very less and it gives a precise docking. That's why I have done all the experiments in our NAOT test site, and now it is a promising solution.
You told about wireless in
Yes.
underwater.
Yes.
If in oceans, like it's salty water, so it's a conductive medium. So through wireless charging, the efficiency will be very low.
Correct. What we see, we cannot get 100% efficiency like in terrestrial. So in underwater, salt water, when we go with the low frequency, see if we go for higher frequency, attenuation will be very high. But when you go with low frequency, attenuation is not much. Almost now we got in salinity water, we got around 65% efficiency for charging the battery. So that is enough.
At what frequency?
At is 80 kHz. Gigahertz only will be higher frequency, very high frequency is gigahertz.
Good morning.
Yes.
Like whatever problem statements you give, can we implement deep learning for that?
Yes, we have to implement deep learning.
Okay.
Detecting the docking station, camera cannot visualize in turbid water. So when you are going normally, HD camera or SD camera can see an object in underwater only from 5 meters distance. You cannot see like a drone from kilometers. Okay. So deep learning algorithms are very much required now.
Okay.
Thank you, ma'am. We request Mr. Chris Ostrander to facilitate Dr. V. Balananagan. The next keynote session is by Dr. Pranesh SP, scientist of NIOD. I call upon Dr. Vasant to introduce Dr. Pranesh.
Dr. Pranesh SB is a scientist and engineer at NIOT Chennai, which is under Ministry of Earth Sciences, Government of India. His research focuses on deep sea engineering, underwater vehicle design, pressure vessels, and human-occupied submersibles and ocean technology systems. He works in Deep Sea Technologies Division, contributing to the design, structural analysis of critical components used in manned submersibles, remotely operated vehicles, and deep sea exploration platforms. His expertise includes finite element analysis, stress and buckling systems, buckling analysis, hydrodynamics, and pressure hull design for deep sea vehicles, Dr. Pranesh has authored 25 plus research publications related to underwater robotics, deep sea systems, including studies on spherical hull system, pressurized hulls, and CFD analysis of submersibles, hull forms, and safety evaluation of deep sea vehicles. His work contributes to national initiatives such as deep sea exploration and development of human occupied vehicles, HOVs, for scientific research. We welcome you, sir, for your keynote session. Thank you.
Good afternoon, everyone. Thank you, Dr. Vasan, for the nice introduction. I would like to thank Preeta ma'am as well as the Venkateshan sir for giving me an opportunity to be a part of MTS Techsurge. So, I would like to thank the previous speakers, Mr. Chris, as well as Sivadan Pillai sir, for giving an overall introduction about the underwater robotics, and ma'am, Jyoti ma'am, she spoke about guidance, navigation and control. My area of specialization is mainly on engineering design. I always think about design, analysis, integration and testing. Today I want to change a little bit from the traditional presentation. Like I always talk about the success stories. So I changed the presentation in such a way that what are the issues or problems which we have faced during our success stories. So Chris talked about the pathway towards the marine science and technology. So here the challenges or the problems we have faced towards the success of ocean science and technology. So the topic of my presentation is named it as engineering challenges in underwater vehicles. So this is the content of my presentation. I will talk about a little bit about the introduction, motivation, some basic slides about the design as well as the analysis, and some engineering challenges. See, what is motivation for us to develop this ocean science and technology? We have got a thin layer of water above the Earth's surface. There we have got a lot of minerals. We humans wanted to explore more and more and to extract the resources what is available on the seabed. So as well as these underwater vehicles are used for scientific exploration, defense purpose as well as environmental monitoring. The takeaway from this is that the extreme environment or the harsh environment, the high pressure and low temperature environment needs a complex engineering. The underwater environment, so the literature always says that it's a harsh environment subject to high pressure, low temperature, and it's a corrosive environment. All underwater vehicles which goes under the water will be exposed to salty water. We have got a limited or no light, so we need to have lights and cameras to capture the underwater photos as well as videographs. And we have got an unpredictable current. That means underwater disturbances. So we need to have a proper guidance, navigation as well as controls. And we have got a limited communication. That means we do not have any radio waves under the water. We have to depend on the acoustic communication. That means we have got a very limited communication. So if we compare this with Himalaya, that means the Mount Everest, that is 8,200 meters in height, that can be fitted inside Mariana Trench. And in the world, we have got two vehicles that can go up to a depth of 1,000 meters. One is deep sea challenger, another one is limiting factor. So this limiting factor, that's a maximum that can carry a human to a depth of 11,000 meters. So this is the various properties of this, how the profile varies with respect to depth, temperature, salinity as well as density. When we go down, the pressure increases as well as the temperature decreases. There is a sudden drop in the region. Approximately for the deep water, it is approximately in the region of 200 to 600 meters. That sudden change we call it as thermocline region. And at the depth of 6,000 meters, we normally see a temperature of 2 to 4 degrees centigrade, and it will be subject to 600 bar pressure. And there will always be an increase in the density when we go down. And the surface we see 1025 kg per meter cube, and at 6,000 meters we see 1060 kg per meter cube. So the pressure changes with respect to that. So pressure increases for every 10 meters. I mean, it's like a linear profile. It's a rho GH, and at 1000 meters 100 bar, and at 6000 meters it is going to be 600 bar, and again temperature is of order of 2 to 4 degrees centigrade. So when the pressure increases, the thickness of the structure goes up, and when thickness of the structure goes up, weight increases, the buoyancy model increases, size of the vehicle increases, power increases. There has to be a trade-off. We have to make a trade-off. So we always deal with the two types of pressure casings. One is pressure compensated casing, another is pressure rated casing. And the pressure rated casings, we deal with this cylinder as well as spherical shape. These are the two preferred shapes for the underwater applications. And for the pressure compensated system, some of these systems like transformer that can be exposed to oil will be fit inside the casing, and it will be connected to a pressure compensator. Here we take the advantage of the weight reduction, whereas in this case of cylinder as well as spherical, let's take a cylinder which is of approximately 300 mm radius. We need approximately 30 to 35 mm thickness for titanium material. And for spherical pressure hull, this is made of steel, SA5 grade 70, need approximately 28 mm thickness for 500 meters application. Again, it depends on the diameter of the pressure vessel. Here it is 2.1 meter radius. And we always choose a material which is compatible for seawater application. We prefer aluminum or titanium. Again, stainless steel also. For problem with the steel is that weight is going to be high, and the future is going to be composites. So coming to the hydrodynamic drag, suppose if the vehicle is moving or the fluid is moving, it is subject to a hydrodynamic drag, and it is a function of this velocity. It's a square term. We always compute this power requirement for the drag. So the inference is that the vehicle is moving at a high speed, the energy is expensive. This is the drag or resistance curve for any vehicle. This is the shape. So suppose if the vehicle is floating, that means it becomes a positive ion, and we always prefer a system which is of neutrality or little positive ion. If you take an ROV, it is a floating vehicle. AUVs are, we prefer neutral bind. Neutral bind is not possible, but we always have a little higher positive bind. So coming to stability, so we got to design a system in such a way that vehicle always has to be stable. So we got to see that the center of buoyancy is above center of gravity, so that if you tilt a vehicle or if you have some external disturbances such as like current, the vehicle comes back to the original position. So this Reynolds number plays an important role in model studies. Suppose if the vehicle is completely submerged, we have to take this Reynolds number. Suppose if the vehicle is not submerged or the floating, we have to take a float number. The problem with this Reynolds number is that this Reynolds number is a function of velocity as well as the characteristic length of the diameter. These both are, suppose if I take VD as a constant, it becomes inversely proportional. Suppose if I have a particular size of the vehicle, you have to increase the speed or increase the size. Both are, it is very difficult to carry out the model study. So we have to have some kind of trade-off here. Again, on the energy and endurance part, we have got an AUV as well as ROVs. In the ROVs, we have got unlimited power supply because it is connected through umbilical cable. Whereas for AUVs, we have got a batteries inside, so we have got a very limited power supply. This energy budget is a function of the power, and mission duration we need to calculate based on the power availability or supplied by the battery or based on the selection of the battery. And gliders are little modified version of the AUV. It always optimizes the efficiency. That means it uses a buoyancy engine, or when it goes down, that downward movement is being converted to forward movement. That's how this gliders works actually. Reliability, whatever the system which we design, it has to be reliable, because when we go for a sea trial or when we do a technology demonstration, failure is not affordable. So this reliability has to be taken care at the design stage itself by having a redundancy. We can have a fault detection mechanism. Even though there is a fault, the system has to work, or it has to come back to the home position. So these are the systems which were developed at NAOT. We have got a ROSUP 6000, which is rated for 6,000 meters out of depth. We have got another ROV that is for 500 meters. That's an inspection class ROV. We have got another mission, ACS 3000. It's an autonomous scoring system that's used for taking samples below the seabed at a depth of 3,000 meters out of depth. And these are the two systems under development. One is Matsya 6000. That's a manned vehicle rated for 6,000 meters. We wanted to take 3 human beings to a depth of 6,000 meters. And always there is a question. When we have remotely operable missions as well as what do we need this muscle, because it's a risky operation. We always believe that seeing is believing, one. Second thing is, the human eye cannot be replaced with the latest technologies. Third reason is that in future, we wanted to have maybe possible that we wanted to have settlements at a depth of at a deep water. So we want to have some kind of transportation from surface to the deep water. So that's keeping that in mind. We are developing a man submersible rated for 6,000 meters. This is another vehicle that is AUV rated for 6,000 meters. It is only 6,000. So we are in the process of developing this. That's going to be the future. Right? It's only a technology demonstration for this man submersible. But again, some robotics, AUVs are going to be the future. So this is the ROSUP 6000 rated for 6,000 meters water depth. So this is the entire system which is loaded on the ship. This is a ship crane. We call it as LAS, Launch Retrieval System. This system is called ROSUP 6000. It has got TMS at the top. This is the ROV. Here we have got a deck-based winch. Here we have got a direction changing pulley. So this is rated for 6,000 meters water depth. It is launched from the ship. So now I'll move on to the challenges or issues which we have faced during the success of this particular ROSUP 6000. So we wanted to have a sea trial at CAOB. So before going to CAOB, Central Indian Ocean Basin, totally south of Equator. So we have to travel 7 to 8 days to go to CAOB. Before that, we want to test the system in underwater, close to Chennai. So we have taken this to Chennai port. There we are launched. We were testing the system. During the testing, we found that, during the process of the testing, because of the repeated cycles, one of the bracket of the propeller system has failed. That is because of the fatigue failure. Then, suppose if you are moved to CAOB with this system, this we take approximately 8 days to travel, approximately 2,800 kilometers from here by ship. This failure is not affordable actually, because we cannot come back. We do not have any space for this particular system, and moreover, this direction control. This is again an important subsystem that needed for the maneuvering of this particular system. So we have replaced the system in the local. Then we have proceeded to CAOB trials. This is another failure or challenges we often face with the umbilical cable. Umbilical cable is a combination of mechanical, electrical, that means power, as well as we want to transfer the data to a depth of 6,000 meters. This particular cable will be subjected to tension, bending, as well as torsion. And this cable, when we are loaded onto the ship, it will be exposed to UV rays. So obviously there will be a temperature expansion as well as contraction. So this particular failure, that's called kinking. As well as if you see this particular failure, the outer sheath is broken actually. So often this particular problems we face because of the manual error. So we cannot operate this or lower the weight to this damage. So we often, rectify this on board by following a certain standard procedures. After that, we lower the system. See, another problem is the subsea converter. This is a pressure rated casing. Inside it has got a electrical and electronics components which is exposed to oil. And when it goes to underwater, if there is a water failure or because of overrating of the, suppose if particular component is taking more current, some of the components like diodes used to fail actually. Here you see that some of the carbon deposits, once the system fails, so you have to open the system, you have to clean the system completely, and again you have to fill it with oil actually. If the oil is contaminated, again this reoccurring of this problem happens. We always do this, not always. If there is a failure, we have to clean the complete system, again you have to fill it with oil. This is another switch or the contactor. Again it has got a similar problem. This contactor is placed inside this pressure rated casings, and we often face this problem. And this is a power distribution system. It is used for controlling the power to the different systems actually. We have got underwater cameras. Here if you see that all 4 cameras are working, and here if you see that only 2 cameras are working, other 2 cameras are not working. This may be the problem. Sometimes what happens is when it goes to higher depth, the camera may fail. So these are the problems which we face. Always it is good to have a redundant system. So this is another problem which we have faced is that when the system goes to a higher depth, we always face a communication loss. This is through an umbilical cable. See, till it reaches 2000 meters, there is a slowly steady decrease in the loss of dB, and at 2000 meters, sudden loss of dB. So during the analysis, we found that we have got one more system, that is fiber optic rotary joint. It has got an oil fill. So if you have a contaminated oil and it is subject to low temperature, there is a loss in the dB. So we understand that this oil is getting deteriorated maybe in the order of 3 to 4 years. So we have decided to change this particular oil once 3 years. This is another problem which we face is the corrosion on the thruster. This is the neodymium magnet. It has got iron as well as neodymium and boron. When it is subjected to seawater and this is getting oxidized, it forms a corrosion actually. When small bulgings are happening. So because of which, so the effect of the magnet strength gets reduced. So this is one of the powerful magnet that's being used in the thrusters actually. So to not overcome this, after the sea trial, you have to come back, open the system and clean it for the efficient use. This is another hose compression. This is a pressure component of the system. So it is filled with oil, and immediately after coming back from the sea trial, we see there is a compression on this hose. This may be due to that the wrong selection of the hose, or oil is not filled properly, or it does not come back to the original position. That means because of the temperature, the oil gets shrink and it has to come back slowly. It takes a little more time to come back, or if it is not filled properly. So this is the environmental disturbance we see often in sea trials. We always launch a system at approximately at a sea state of 2 or 3, and recovery may be 4 or 5 because recovery is not under our control. This is one of the mechanical failure we have faced during the sea trial. If you see that we have fixed one sample tray here, it's in the horizontal direction, while recovery is in the vertical direction. So we have designed in such a way that the system has to be reliable. Yeah, this is another important or interesting one. So we have sent some of the polystyrene cups along with ROV to a depth of 6,000 meters. When it comes back, this is the size of this cup actually. Initially this particular height was around 100 mm approximately. You see that only 20 mm. That's the size of the cockpit is compressed. Because in polystyrene, inside it is filled with air. All those air gets compressed, and because of the temperature, as well as pressure effect, it has shrink to this level. And we are facing all these challenges to take few samples and costly samples. And this is the polymetallic nodules which you have collected using a core, and this is the water sample which is collected at a depth of 6,000 meters. The quantum of the sample which we collect is less, but the problems which we face is more actually. And the moment we take out the system, we normally clean this with the fresh water. So that is a part of our maintenance, and so that the corrosion problems gets reduced by 20 to 30%. And once we come back to our office or to our workshop, we have to take out all these systems one by one and we have to clean, because if you leave it for a week, the salt deposits and corrosion, pitting corrosion, and the lowering surfaces gets damaged. This is another system that is autonomous coring system rated for 3,000 meters water depth, and for taking the samples below the sea surface for a depth of 100 meters. This is our one of the launching picture. This was the sea trial which we had it in the year 2013. So we were trying to launch this autonomous coring system of Cochin using an airframe. The system is being lowered from the deck. You see this region. There is a failure. This is the airframe of the ship used for launching heavy machineries like ACS, ROV, or even boys used to do that. But during this mission, there was an unfortunate incident, an airframe failure, because of which we had to abandon this particular mission. We had to come back. What I'm to say, the message is that the failure, we cannot afford this failure. We have to take care of the system in such a way that the system has to be reliable during our operation or even during the launching. So these are some of the pictures of the salvage. So the moment it got failed, it has to go on emergency recovery. So entire deck operation was taken care, under the control of the captain. So we had to lift this using another system, that is an airframe, that is not airframe, another crane that is capable of taking 10 tons load. Luckily, this system does not have a magazine. If you have loaded the magazine, the entire system weight goes to 12 tons, then it becomes more challenging to recover this particular system. This is another problem which we have faced. We have lowered this system off Chennai at 100 meters water depth. During the drilling operation, we found that the entire machine was sinking. Then later we found that the area which we have calculated for this lake was not sufficient. Initially, we had only 4 meters per area for 10 tons of this particular mission. Then we have increased to 20 meters per to take care of the bearing strum as well as to take care of this entire mission weight. This is another problem we have faced during the sea trials. So this is a folded foot. The system was launched, and while recovery, we had some problem on the hydraulics. We lost almost all hydraulic fluid, so we had to shut down the system. Then while retrieving, we could not fold this machine. This particular foot. If we cannot fold it, we cannot recover the system. It has to hang on the airframe. So what we did is, still we took a risk of operating this hydraulic, HPU. That was, we had a hole on this particular hose, and the entire seawater gone inside this HPU. Still we operated the HPU with the seawater. We could fold this particular feet, then we have recovered this mission. The problem is that the entire hydraulic system was flooded with seawater. We have to spend almost a month to clean this entire system and bring back the system to a working condition. Then, because of which, we have added two more wooden rods to prevent this rotation of the sea. These are the learnings which are requirement based addition we have had it on this particular mission actually. These are another failure which we had. Suppose you are taking this systems on board the ship. It has all these cables, connectors, hydraulic hoses. It has to undergo or be exposed to sunlight. Because of which we had some of the cable failures, and because of the connector failure, in fact, we had a water entry inside the system. So can you see a small drop of water which is going towards the fiber optic joint? All these problems has to be addressed while going on sea trial by covering with the suitable, some kind of storage systems. This is the maintenance which we had. We have to spend almost 1 month to clean the entire hydraulic systems. This is another failure, that is the corrosion. So once we come back from the sea trial, we have to remove all these cables, connectors, we have to clean it. If you leave it for 2 to 3 days, then there will be a pitting corrosion. Next time when we go for it, so water entry will be there. We will have a passage or there won't be any water barrier. When we are exposing all systems for the water entry. Coming to safety and reliability, all these systems have to be designed for higher, I'm not saying higher factor safety. The moment we say higher factor safety, system weight has to go up. The moment weight of the system increases, the synthetic foam weight increases and it will lead on to the power. So we should have a trade-off, or we should have a proper safety factor while designing the system. The system has to be reliable when we go for the sea trial. That means we have to have a periodic maintenance, preventive maintenance, regular inspection. And the last point is that by combining strong engineer design, preventive maintenance, operation safety practices, underwater vehicles can perform outer tasks and efficiently. Again, I would like to reiterate that during the engineering trials, we cannot afford failure going inside the sea. We have to take care of the system, and the system has to function reliably. Thank you very much. If you have any queries, please.
What sort of intelligent systems do you think that can do some predictive maintenance or something in your underwater systems that can remove all this kind of failures?
Yeah, nowadays this continuous monitoring is in place by having some kind of sensors that is a part of the system that gives you an indication that what to say is automatic information. It comes to your mobile or to your system in such a way that this many cycles are over. This is the maintenance need to be done so that some of the failures can be prevented. Especially onto the spherical pressure hull, we are going to have a healthy monitoring system. Their strain gauges will be embedded onto the surface. That means it gives you a strength or the strain rate or the number of cycles, remaining number of cycles. So that's another way of doing it.
It's a very good presentation and nice to see. I have not seen this many failures actually. Means I have joined late in AOT. So whatever experiences you have seen in unmanned underwater vehicles, you are trying to do any methodology for preventive maintenance, or how you are implementing some best practices?
Yeah. So these are the failures I have seen personally and part of the team since 2009. So the last 5 to 6 years during this trial, we have eliminated almost 100% of this water entry problem. Like that, we have prevented a lot of other system failures during the sea trials. That means the expertise level has increased, or it is like you can say that it's like an asymptotical, which is 70 to 80% is easy. After that, we have to have a consistent effort to reach 99%. So I could see that we are consistent, reliable in sea operation, and self-reliant towards the ocean technology. I think we are doing the best. Thank you very much.
There is one more question. Good afternoon, sir. Sir, I wanted to ask that if there is any system failure, so is there any method or way to like how we can recover our boat? Like,
see, it depends on the what kind of system is being failed.
Like related to power. Is there any type of?
Normally, what we do is when we go for a long sea trials, like normally this ROVs, when we go to COV, Central Indian Ocean Basin, or 20 degrees south, we cannot come back. There are situations we used to come back actually, but again coming back from 26 degrees south to Chennai and going back for the sea trial, and we'll be getting a very short period for the sea trials. So what we normally do is we take enough spares with us, 1-to-1 spare. So we try to replace. That means we got a skill to design, develop, as well as maintain. So that's the sort of skill we, enable and sort of.
Anyone else?
Thank you very much.
Thank you so much, sir, for the insightful PPT. I asked Dr. R. Venkatesan to felicitate Dr. Pranesh. Next, I'd like to invite Dr. Vasant to introduce Mr. Dinesh Babu to give the next keynote lecture.
Dinesh Babu, SO, Director of Samhita Private Limited and Managing Director of KEM India Private Limited, who has founded Samhita Marine in April 2017, primarily focusing in providing business support services to its world-leading associates to various Indian government organizations, R&Ds, and industry and academia. Established KEM India as a subsidiary of KEM, delivering subsea technology, OBS, and end-to-end turnkey solutions. Started his career in early 90s and worked on various scientific research markets, including oceanography, learning the technology, working with customers and associates. He has been instrumental and part of the team establishing critical and national infrastructure such as Indian tsunami warning systems, land-based seismic networks, delivery and commissioning and integration of niche scientific equipments on research ships of various institutions, including deep sea mining, deep sea technologies, and survey and solutions. High-tech systems for various mission mode projects, manned submersibles of Ministry of Earth Sciences and various DRDO projects. We welcome you to deliver the keynote session, sir. Thank you.
Good afternoon, everyone. Perhaps it's at the end of the day, and rather end of the morning. Perhaps everyone is waiting for the food. So I'm not going to keep you long. My presentation is about unmanned underwater systems. So perhaps a couple of more than 3 speakers in the past have talked about underwater systems, and so Samita, probably what does it mean? Samita means, somebody was asking me what Samita means. Samita in Sanskrit means together. It's like coming together, we deliver. That's probably the concept. We probably want to explore deep and beyond, believing in what we do. This is some of the associates we work with. They are our identity. Customers we work with, which is our visibility. Today's topic is more about the unmanned systems. I'm going to talk about what goes in more on autonomous systems, autonomous vehicles. Various types of unmanned vehicles are there. We have autonomous underwater vehicle, AUV, or we have manned submersible. We have remotely operated vehicles. All are underwater systems, but every system comes with its own abilities and complications. Why ROV? Why AUV has its own reasons? Why manned submersible has its own reasons? But MIOT started discussing manned submersible as a mission. Probably we got involved with that program, and probably from then we have been working. Now, why manned submersible? Why do you want to risk putting 3 people inside a sphere and sending them down to 6,000 meters? Like, then probably the question and also the answer is, risk brings you the ability to also see things completely different. Like with an AUV, we can do the same thing what you want to do with the manned submersible, but you cannot go as close to that location and see those things what you would see otherwise in AUV based environment. In cost wise, AUV can do remain like the AUV will cost maybe fraction of what a manned submersible mission will do in terms of development. Not only development and owning a manned submersible, operating manned submersible also would mean a lot of paraphernalia, vehicle, vessel, and also the launching and recovery systems, so on and so forth. And also very expensive things like going for class certifications and all. Perhaps this slide shows what all goes in those unmanned systems to make things work. You see on the left side, if you see, sorry. You have inertial navigation system, you have positioning system, and you have side scan sonars, you have batteries, you have cameras, you have communication systems. So perhaps what I'm trying to show you is you have the eyes, ears, and ability with those, like basically if you don't have these senses, you probably will not be able to go autonomously and do the work that you intend to do. So you have inertial navigation system which gives ability to see and do your navigation in an defined environment. So basically you need batteries, which this is the battery what we use for on the right side when you sit on that. You have the batteries which we use for submersible program. And we have the acoustic positioning system which you see on the left side, which helps you to determine the position of the vehicle when it is deep under at 6,000 meters water depth. You need to be guided in the positioning and also the navigation systems. So various payloads which goes in like multi-beam echo sounder, single beam echo sounder, suborder profiler, side scan sonar, SAS, and also position and navigation system like USBL and long base line systems, real-time kinetics, GPS systems, which only helps in the surface positioning, but those are required to give guidance to the inertial navigation system. When you are blindfolded in this room, you can be trained and asked to go from one point to the other, but when in a position denied environment, like when you go deep sea, when you go deep down, you are completely guided by inertial navigation system. And so the initial references is given from the GPS, but then the inertial navigation system takes over from there. And also the motion reference units and various types of those sensors. And to see things, you have cameras, you have lights, you have sonars, in many, in such depth environments, in such deep environments, most often the cameras do not work and sonars comes into play. And you have various types of sonars like single beam sounders, multiple beam sounders, or synthetic side scan sonars. Depending on the requirements, you get those sensors what you want to get things wrong. So you have remotely operated vehicles and autonomous underwater vehicles. So as I said, where AUVs function most efficient is when you want to go explore things and get visuals, imagery and come back. When you want an intervention, it is ideal that you use a remotely operated vehicle. When you want to get that closer, that deeper, and also want to get the feel of what is happening at that place, then you probably will be better off to go with the manned mission. So, in an AUV environment, we have communication, navigation, and guidance and control. Everything plays a very critical role. So, when you want to go from a particular location on a mission plan, when you want to go down, find it, and do that mission and come back, you need the best guidance and control, which is actually giving the required information to your thrusters to go and do the job. And your inertial navigation system and Doppler velocity law and depth sensors, they guide the vehicle to go and do the mission. And when you go and do mission in such deep environments, when you have imageries and when you have data captured there, and you need to communicate back to the mother vessel, so that you have acoustic communication system, which brings the data to a certain extent. State of health, not every data can be transmitted in such deep environments. Only the state of health information is transferred to the mother vessel. And from the time, you also need to know where the vehicle is compared to the mother vessel. So that will be guided by the acoustic communication system. One critical thing which is also developing it. This is from a company called International Civil Engineering, which developed this technology way back, and I'm so proud that today as a country we are ourselves developing it. NIOT, one of our past speakers, is involved in this project. At NIOT, we are also building and developing a homing system and also underwater charging system. So the reason for these types of things is that when you go and explore things, the vehicles need to come back. The vehicles, when it's surface, typically it consumes more power. When you surface and then when you want to dive deeper, then it takes more thrust, because once you cross the barrier and comes to the surface, to dive back you need that much more power. In an autonomous vehicle, what is more important is that how power efficient you can make them, how less power hungry your systems can be. That much more longer you can employ your vehicle to do the job. So probably one reason to counter and to overcome this obstacle is having a homing system, a docking system, which can be used for collecting the data and transferring the data to Facebook, or also to charge the underwater vehicles in different depths. Like Jyoti mentioned, every 30-40 meters water, we can dock it, we can charge, and we can also recover. So this is one another new thing which is under development in event is called Bio-Inspired Vehicles, and a short video which shows the biofins, when probably the manta ray, which type of things which makes your vehicle to work more efficiently. So unlike normal propulsion system using the thrusters, you have biofins to maneuver the vehicle. And of course, this particular technology is under evolution. It's very challenging. Like the bio-inspired vehicles, I've seen this. This is technology collaboration with the University of Berlin, TU Berlin, and as many actuators, there are small and very minute parts which are involved in this. To get everything to work in tandem is a very challenging thing, but there are people who are working on this technology. Like manta ray, there are people who are working on fish based mimicking, and biomimicking is what we call it. And IIT Kharagpur is working on some of these advanced biomimicking platforms also. IIT Kharagpur and also CMERI Durgapur, they are working. And I'm sure NIOT is also trying to work on biomimicking. So there are a lot of people who are trying to work on biomimicking because this is the most efficient way rather than using just a propulsion system to thrust and move forward. Biomimicking will make things a lot more easier to work in the underwater environment. So probably that's probably my last slide. So what Samhita Marine is doing is we are, along with the national institutes, we are working as a bridge between the technology, what we are evolving and what we are trying to get. So we work with companies in the international arena to try and bring those technologies and also bridge those technologies and build those technologies in the Indian context. Now, if we build technologies only for India and India projects, probably this is not the way to go. Now we are also trying to talk with our associates in Europe and Americas to see if we can bring those technologies, value add the technologies in India, and make those technologies work for India and make in India, and also use India as a platform where we can build it and also, market those products for the countries in this part of the world. So probably that's all what we intend to do. And as an industry, probably we're looking at collaborations at that level where we can jointly make things work together. So together we deliver. So we need collaborations rather than looking at everyone doing everything. And now probably as many speakers will be there in the afternoon from industry. Everyone is working on underwater vehicles. Most people are working on underwater swarms, platforms, and so on and so forth. So probably I've been talking on this platform even last year when we was here for AA for Motions. This one topic what I was asking is to accelerate things. Probably it will be a better idea where we will start collaborating rather than everyone trying to do everything. If we collaborate, maybe if we take one thing and if somebody else takes another thing and then focus on those areas and then bring that collaborated synergy in an ecosystem, then as a country I think we can evolve. If we have to make a product and deliver it to the market, a synergy is important. Academia, industry, and also institutional framework. If we can work together, probably we can deliver that much far better, that much far quicker, that much more efficient. So together, let's deliver. As I started, Samhita means in Sanskrit together. Samhita Marine came from the background that together we deliver is a concept. Have a great day.
Thank you, sir, for the amazing lecture. Next, I would like to call up Mr. Chris Ostrander to felicitate Dr. Dinesh Babu. All poster contest participants, please go have your lunch. Be back by 2 sharp and be at your poster stands by 2. Lunch will be served at Tech Park 1. If you need help finding your way there, please look for a volunteer.
We have multiple canteens there. You can go either Tech Park 1, 2 or even Java. Have your lunch, come back at 2 o'clock. We'll be starting the poster competition by 2 o'clock. Thank you. Sharply 2 p.m. we'll be starting the poster competition. Please don't delay.
இல்லை லைவ் அப்புறமா போட்டால் போதும் இப்பயும் போட்டீங்க லைவ் வேணாமா
World applications, including autonomous and robot used in complex environment such as industrial automation and outdoor robotics operation. His research group also explores mechatronic systems and advanced manufacturing technologies to improve the performance and adaptability of robotic devices. We welcome you, sir.
Hello everyone, very good afternoon. First of all, I'd like to thank the organizing committee for having me here. It's always a privilege to be here in this campus. So this talk, and thank you very much for the warm welcome and the introduction. This talk will be on one particular category of underwater systems, which is underwater gliders. So underwater gliders, just to give a brief introduction about underwater gliders, this is just one segment of a vast variety of underwater systems that are available. The talk that I'm going to do today is just kind of a 101 lecture on what is an underwater glider, what is expected from an underwater glider, and what are the capabilities, how do we improvise, and what are the challenges and opportunities when it comes to underwater systems, underwater gliders. So let me just give a brief of the kind of applications and some of the terminologies that are associated with underwater gliders when we talk about it. Usually underwater gliders are torpedo shaped, and this is the kind of shape that you can expect with some wings and rudder and so on and so forth. We'll discuss about this in detail later. But some of the things that usually the underwater gliders are associated with is that it is suitable for long duration missions. It is one of the most energy efficient systems, and it is under actuated. The focus of today's talk will majorly be on, emphasis on these three segments. Why is it so? Why is it suitable for long endurance mission? How is it energy efficient? And how is it under actuated? So these are some of the broader applications of where the underwater gliders are used presently in the market. So wherever we generally deploy autonomous underwater vehicles or remotely operated vehicles, it can actually perform there as well, but it is majorly used for missions which require data collections for longer duration at deeper depths. So one of the applications is oceanographic and climate monitoring, environmental and water quality, surveillance, operational forecasting and support, and acoustic maritime domain sensing. I'm not getting into the details of each of these things. I'm pretty sure we all can understand the application point of view. But the emphasis that I wanted to bring in here is on the design of the system and some of the novelties that one has when it comes to underwater gliders. So these are some of the major players when it comes to underwater gliders. Sea glider and spray glider are predominantly used for within the US and within US Navy. Slocum is a commercially available underwater glider. In fact, we have a few Slocum gliders within India Excel, which we purchased and used for coastal surveillance and also for oceanographic data collection and so on and so forth. Although these are some of the systems which are commercially available, when it comes to the cost, when we purchase from outside, it is very, very expensive. Of course, if we can make it indigenously, we can reduce the cost significantly. Right? That is the perspective from which we are also looking at why don't we have indigenous underwater gliders. So underwater gliders predominantly work based on variable buoyancy. So this is something that one should understand. What is variable buoyancy? Right? All of us know any system that is submerged underwater is going to have two forces. One is the weight and the buoyancy. Right? So if we can have some sort of a imbalance between this weight and buoyancy, if the weight and buoyancy are equal, we call the system as a neutrally buoyant system. If there is some imbalance, let's say if the buoyancy is more than the weight, then it is a positively buoyant system. Or if the weight is more than the buoyancy, then it is a negatively buoyant system. So if I can modify that, we call that as a variable buoyancy system. So one of the major units of any underwater glider that we take is a variable buoyancy system. So what is the purpose of this variable buoyancy system? It is going to enable the force imbalance in the vertical direction. It is going to effectively make the system move vertically. Right? So this is one part of the system that one should have. And another related term that is associated with this variable buoyancy is its power efficiency. So think about this, right? You have some system which is neutrally buoyant, right? The forces are balanced, it is under equilibrium. And now you bring in some inequality. So you have to bring some delta W or delta B, which is that incremental buoyancy or incremental weight difference, right? Until that period only you are going to consume some energy. Right? Let's say you might probably take some 10 seconds to bring that imbalance. Once that imbalance is achieved, the system is going to continuously keep moving. For instance, if you are at the surface, let's say that is 0 meters, and if you want to go to 100 or 1000 meters, right? The energy that you are going to consume is just on the surface, probably for some 10 to 15 seconds. Right? Beyond that, since the system is, it's not in its equilibrium, it is going to continuously keep moving. Unless you change the state, it's going to continuously keep moving. So essentially, for that system to move, you're just consuming power in a very shorter period. That is one of the biggest advantages of this autonomous underwater gliders. So, since it uses this variable buoyancy system, autonomous underwater gliders are typically 3 degrees of freedom systems. So, the degrees of freedom are, it can travel along this Z axis, which is usually associated with heave motion, and it can also move along this X axis. So, if you see, the gliding takes place like this, right? So, this is usually called as a yo-yo motion, right? So, it can actually dive down and dive up, and then it continues. Right? So during this dive in and dive out, it can actually reach a particular range. So from the starting point to the point where it surfaces out, this distance is usually called as the range, and the depth that it can traverse is represented here. So typically, the moment it starts to dive in, it dives at a particular glide angle, and this is another parameter that one should be associated with. So the moment it starts to go down and come up, whenever it reaches the surface, the communication happens, and then once it dives down, there is no other communication. See, one of the important advantages with this underwater gliders is that it is a very power efficient system. And because of the way it is power efficient, it is also a responsibility of us to keep it power efficient. What I mean is, we don't want to waste the power in any other ways, like we do with autonomous underwater vehicles or remotely operated vehicles or any other segment of underwater vehicle. So usually, the moment the system dives in, we just start to collect the data and no other operation happens. And we will get to know everything only when it comes to the surface. So until then, we have to make sure that the system is reliable and stable under the water. So this is one of the modes of operation of an underwater glider, and you can see there are 3 degrees of freedom in this system. And in many cases, it is also important for us to correct the yaw. So this is the ideal situation where the glide happens on a plane. But usually that is not the case. We should also be controlling the other degree of freedom, which is the yaw. So the 4th degree of freedom, on demand, we will be correcting. So although it is typically 3 degrees of freedom system, we should be able to control all the 4 degrees of freedom, and that is why you have a variable buoyancy system that is the heart of the system. And there is a mass shifting system. This is what enables us to pitch down. So essentially from here, which is horizontally, it has to pitch down to move on the glide angle, and that is enabled using a mass shifting mechanism. The purpose is it eventually helps us to control the center of gravity, and thereby you will be able to pitch nose down and nose up. And that is done by this mass shifting mechanism. And of course, controls, battery, all the electronics will be there. On emergency basis, if you need a thruster can also be activated, although thrusters are not always used with this system. And as I mentioned, there is going to be a rudder. And this motion, which is vertical to diving down and diving up, basically the vectoring of the forces is done using the wings. Now, let us see how this glider works. Usually, if we have, let's consider this as a system with a variable buoyancy system alone. The kind of motion that we can expect is it can only move up and down. It can only achieve a vertical motion. And here the depth is controllable by achieving a balance between this weight and buoyancy, variable buoyancy. And the other mode that we can also try is using this mass shifting mechanism, as we see here. If you can shift the center of gravity position in such a way that you can pitch it nose down, along with this variable buoyancy, it is possible for you to again move up and down, but it will be pitching down and then moving up and down, which is again not of very much use to us. That is why I put a slant line here instead of having a vertical line. But this combination, along with the wing, can actually do what we actually want. So the moment you attach a wing to this two combination, it is going to effectively vector this vertical motion along a particular direction, so that you can actually achieve this gliding motion. And as I mentioned, depending on the case, if you want a rudder for you to correct the yaw, it is also necessary for us to have this rudder. So essentially, you have 3 controllable degree of freedom. For instance, you have the variable buoyancy, which is a controllable degree of freedom, and mass shifting mechanism is also controllable, and rudder is also controllable. So you have 3 actively controllable mechanisms and 4 degrees of freedom. So that is why we call this as under-activated system. You have 3 parameters as input and 4 parameters that come as output. It is an under-activated system. Now, there are some interesting factors that we have to understand when it comes to underwater gliders. One is, when the system is positively buoyant, it stays on the surface. I mean, it is completely buoyant, it stays on the surface. And the moment you make it negatively buoyant, right, for you to make it negatively buoyant, you have to first do certain things. One is, from positive buoyancy, you make it negative buoyancy, and also shift this theta. I mean, you have to shift the mass towards the nose side so that it becomes heavy towards the nose and it pitches down. Right? Once it pitches down, it starts to move along this direction. While it moves, it is negatively buoyant. Right? And now you will eventually be able to go till here, and at this point there will be a state change happening. And the state change will be from negatively buoyant situation to positively buoyant situation, with making this towards nose up. Right? And that is what is happening here. So once it is made nose up and positively buoyant, it starts to move along this side. Right? And once you reach the surface, again the same cycle repeats, and this is exactly what an underwater glider goes through in each cycle. Right? And when as it is required, you will also be using the rudder. Right? The most important thing that one should understand here is how do we say that it is a power efficient system. So if you look at this, there are multiple cases of power consumption. One is proprioceptive sensing. One for you have to dive down and dive up. You have to monitor your own sensor data. Right? That is what we call proprioceptive sensing. And the other segment is exteroceptive sensing. Whatever data that you collect from the outside, like the oceanographic data and so on and so forth. So those are exteroceptive data. And Apart from that, the major power consumption happens, as I mentioned, during this transition. So when you have this positive to negative buoyancy and negative to positive buoyancy, you can see that the variable buoyancy engine consumes a lot of power. And especially when you are at a particular depth, at a higher depth, the power consumption will be much higher for the variable buoyancy system itself. So this just gives a rough idea of what are the kind of power consumed and in what situation the power is consumed in an underwater system. Of course, the scale is not, it is not appropriate here. In fact, for the glider which can travel up to 1000 meters of depth, this part of the power will be the highest. Right? It will be almost more than 3 times of the power consumed from the surface for the glider which can go up to 1000 meters. Fine. So any underwater system, as we see, any robotic system for that matter, will have some sort of modeling that has to be performed. The objective, one of the objectives is basically to predict the performance of the system. For instance, if you want from the top view, right, if you want the system to start from here and dive in and dive out till this point, like you see here between these 2 points, it has to dive in and dive out. And these are multiple such dive in and dive out cycles that you expect it to happen. What happens in general is this is the anticipated or the planned path, but in actual there will be a deviation. Of course, that is expected because of the underwater current and other disturbances and so on. So you expect some sort of a disturbance to happen, right? So that disturbance is eventually going to make you deviate from the original path that we expect to move. And in that case, is it possible for me to have some sort of an in-situ performance monitoring and correcting on the go, right? From that perspective, it is possible, but the fundamentals behind that is to understand and predict the behavior of the system in simulation. So how do we do simulation? We have to mathematically model the system. So the next attempt is to mathematically model the system. I'm not getting to the details of each and every element of this mathematical model, but this is a very generic and well-known mathematical model that is available in literature, right? Thanks to Professor Thor Fossen, who gave a generic understanding of what a mathematical model of the system would look like. Of course, this is the Newton-Euler approach based on the Newton's law and also the Euler's theorem. It is a combined approach to have both, translational and rotational degrees of freedom integrated along with the drag and add and components. So ultimately, the entire dynamics of the system can be, understood with this sort of an equation here. So just to simplify and give an example, this is as good as having a particle moving in a space which is well defined, right? We all know F is equal to ma. So if you know the mass of the particle that is moving and given the input as the force, it is possible for us to predict acceleration, velocity, and position, the entire trajectory of the system. It is an exaggerated version of the same with all the elements that we would expect when the system is deployed underwater. What is more important is to understand the actual degrees of freedom that we require. The purpose of this slide is not to scare you, but it is also important for us to understand that this is a very important exercise that we do. And at least in this slide, more than 80% of the content that I have here are all based on literature. Just most of the cases, the mathematical model will be available in the literature, right? It is just, for your own system, you might have to improvise the system, improvise the equations. So this is the generic equation expanded from the previous 6 degrees of freedom model. This is for 3 degrees of freedom, surge, heave, and pitch, right? And since we are also using the variable buoyancy system, in this case we use a linear actuator to increase and decrease the volume, we have to include the linear actuator dynamics as well, and along with that we will also have the ring dynamics. So for us to understand, we can just understand the system as a whole with this. The objective is, if I give some voltage as input to the linear actuator, it is going to start to expand. Because of that expansion, the volume is going to increase. When the volume increases, the initial forces, the buoyancy is going to increase, and that is eventually going to generate a motion along the system. And once we have the mathematical model, right, it is possible so what is the purpose of mathematical model? I want the system to be predictable. I want to predict how the system is going to behave, and it is possible for us to do all these sort of simulations. So just to simplify, I give some input voltage to the actuator, which means when I give some positive voltage, it is going to go from negative to positively buoyant, and negative voltage means it is going to compress. So you can see that the system dives down and it comes to the surface and so on. So if I repeat this on a cycle, it is going to dive down and dive up and so on, right? So this is one of the predictions that we do. But what are the things that we are actually interested in? Are the forces that are acting on the system, are they nominal? Is it optimal, right? Or should I do something else so that for the same energy that I use, I'll be able to dive in efficiently? These are some of the questions that we will try to answer using this mathematical model. And once we are sure that it is going to work perfectly in the way that we expect, we will freeze the model and we will try to do. So some of the challenges here in the mathematical model itself is that we will start with some assumption that this is going to be the parameters of the system. And eventually, we will try to implement it, the system is going to evolve. Right? And based on that, again, it is mandatory for us to come back and update this mathematical model. So it is an iterative process where the entire thing is looped. Right? So the challenge here is how do we estimate the parameter? And till date, the only perfect thing that you can do is under lab situations, you can estimate the parameters and you never know to what level you are accurate compared to the actual system. But it is very, very important to do that still, because we will be able to predict at least to a certain extent how the system is going to behave. Right. So using this mathematical model, there are some of the challenges that we can actually solve. One is, how do we make sure that the glide angle that we want is precisely maintained, right? So typically the glide angle ranges that we want for any system that we want is between 18 to 21 degrees. Right? Of course, can be varied as you can, if you want, your requirement is such. It is possible for us to change that. So 18 to 21 degrees is one particular range where it is usually preferred. Right? Now, while we do this, if there is at some point, let's say there is some deviation because of some sort of a disturbance, right? You are going to get deviated from the way that you go. So this is the expected path or the trajectory through which you are expected to go. Now, because of some disturbance, you are right now here. Now, after you do this, if you still continue to do that, let's say you correct it and do, you are actually going to come out of the trajectory that you actually expect to do. Now, using this mathematical model or some sort of a algorithm, is it possible for me to say that this is the actual trajectory through which I have to go? Instead of me correcting it on the go and going along some new trajectory, is it possible for me to come back to the original trajectory that I expected to go? So these are some of the things that becomes challenging when we actually do. The most important challenge here is we don't have much computation here. That is another factor that we have to also account for. And some of the other important things like estimation of the endurance and accordingly changing the trajectory that you want to go. Initially, let us say that the trajectory that you expected is something like this. You wanted to have a shallow dive and short range, but let's say there was some resource changing, some resource planning, and some endurance estimation has to be reappropriated. In that case, is it possible for me to adaptively change the course of motion? So these are some of the things that are possible with the underwater systems, and especially when it comes to underwater glider, without using much computational resource, without using much power resource. Is it possible for me to do on the go? That is another challenge that one has to think about. And of course, on the go monitoring the fault and critical parameters, and if there is any updating the entire schedule, and how do we go about doing this? So I just thought of giving you a broad outlook on what are the different steps that one has to do when you want to visualize an underwater glider. We are in fact fortunate to work on Deep Ocean mission along with Professor Preeta here from SRM on developing a digital twin. So we are just not interested in developing underwater glider. We also want to have some sort of a inbuilt intelligence to the system along as digital twin. Right? So in the process, of course, we start with the mechanical design. There will also be a mathematical model. There will be a back and forth, functional loop between this mechanical design and mathematical model. I'm not getting into the details of each and every component in the interest of time. Once we are finalizing on these loops, we'll go back and develop a user console and then some sort of a visualization, and eventually combining these two will give us a digital twin of the system. So there are some other advantages when we and challenges when we try to use digital twins for any system. For instance, generally for underwater gliders, once you have the entire system implemented, you'll probably have a conventional closed system as we see here. So you'll have a trajectory planner that gives the plan of what is the trajectory it has to go through, and if you can observe the states, it is possible for you to control the states, and the system we can close the loop. But the moment if you have digital twins, right, it is also possible for us to have some sort of a supervisory mission control which says what is possible and what is not possible, and based on that we can take some corrective action which goes as an outer loop control input to the trajectory planner. Right? So this is one of the important steps that one has to think about when you try to visualize a digital twin for underwater gliders, and this is exactly the objective that we are actually working towards. Of course, there are challenges with this kind of systems. I'm not getting into each and every component of this, but most important challenge is how do we get the parameters? Like only when you have the mathematical model parameters accurate, you will be able to go to certain level of accuracy. Is that really possible? That is one of the objectives of the project that we are working on. Right. So once we are able to achieve this digital twinning, right, it is possible for us to solve problems in multiple sectors, right, from when it comes to the applications. So we can actually go both from reactive and proactive sectors. We can expand this even further. So it is possible for us to respond to environmental disturbances. It is possible to have some anti-submarine warfare. What is the adaptive strategy that one has to follow? Reliability and safety can be improved significantly. And of course, during the mission, we can say that it is possible for us to improvise the further. It is possible. There are many other possibilities with this digital twins and so on and so forth. So I think with this, I will stop here. If anyone wants to discuss further more in detail about underwater gliders, we can continue a discussion here. Thank you. Thank you very much for coming.
Any questions?
Any questions from anyone?
Thank you, sir. I request Dr. C. Nitya to felicitate Dr. Tyagarajan.
Keynote is by Mr. Vignesh Karthikeyan from MTS Technologies. Mr. Vignesh Karthikeyan holds a bachelor degree in Electronics and Communication Engineering and currently heads the engineering division of MTS Technologies, where he leads the development of advanced subsea robotic system for underwater inspection and intervention. His professional background spans new product development, innovative engineering design, industrial design, high-volume manufacturing across multiple consumer technology sectors. His current work focuses on building reliable robotic systems capable of operating in complex underwater environment, combining electronics, mechanical system, and intelligent design to address real-world challenges in subsea operations. Welcome you, sir.
So most of the infrastructure that powers the world today is something that we almost never see. Thousands of kilometers of pipelines, might be cables, critical assets sit deep underwater and quietly doing their job. But the moment something goes wrong, it's when it becomes extremely difficult to understand what's going on, and it becomes really expensive to deal with that problem. So that challenge is exactly what we work at Planus, and we build robotic systems that can go to places, see things what humans cannot see, and make decisions in environments where reliability means everything. So I want to stress on this word called indigenous slightly more here, because Planus is an indigenous technology company that specializes in NDT techniques. NDT is non-destructive technologies. Planus is going to be about 11 years old very soon. And then initially, we used to operate in a combination of two verticals. First was the vertical that builds robots with the right NDT techniques, and the other that runs operations. So basically, running of these operations in
oil and gas industries such as we have repeat orders from clients like Exxon, Reliance, Shell, which are like top 10 in the country, in the planet, I would say. Today we primarily are operating under two verticals. One is the inspection vertical and defense for naval systems and defense for land systems. We are operating across various offices in India, joint venture in the Middle East. We have a subsidiary registered in the Netherlands, and we have mobile offices in Singapore, Oman, Thailand. That's the scale that we're currently operating under. On our fleet summary, we have over 10 products that are operating in our fleet, and we have over 21 branded patents, and we are HQ in Chennai. So very high level perspective about the product portfolio that we carry. So the first image that you see on the left hand side is our workhorses. So that's Orca, Beluga and Micros. So these are the products that are used to perform inspection services across the planet, all the way in the Indian waters and up to the North Sea. So next is the hydrocarbon tank rover. So Planis is one of the two companies in the planet that is actually certified to operate in hydrocarbon environments. What I mean by that is a fully electric system that is capable of performing inspection services in actively used hydrocarbon tanks. So to give you guys a small example of, let's say if you're tasked to inspect a hydrocarbon tank that's maybe filled with diesel, naphtha, petrol, anything, what they would currently do is they would drain the whole tank, defumigate it, then sterilize it, then make it safe for a diver to go in and start inspecting the tank. All of this is cost intensive. There is operation downtime, and there's still the possibility that it can be dangerous for the diver to face some dangerous situations. So these products are designed to operate when the tank is filled with the liquid and being still in operation. And some products like gel ablokini is where when standard products do not meet the cut, is where custom products are built. So this one was designed and delivered to a defense shipyard that is used for underwater hull inspections. And we have standard AUVs or survey, general whatever the other pitch members read earlier. So Planis is not just building platforms, but also adding the right sensors and payloads, so it makes sense to the customers. Just adding a camera does not suffice, because there is going to be turbidity, there's going to be high current that's going to distort the field of view. Planis's underwater inspection has two main segments. One would be the platform itself, and next is adding the right inspection technique and experience so you get the right data acquired. So Planis is born out of Asia's largest non-destructive evaluation lab, and we have patents on how to run underwater inspection operations. So NDT is in our genes. So just a quick overview, these are really lightweight, portable electric vehicles that can operate comfortably at around 150 meters depth. And whether it is carrying a high definition low light camera or having steel and concrete testing techniques incorporated, or having sonar that can be used for 3D mapping or bathymetry, etc. So coming to these long-range remotely operated vehicles, so these are designed and built to be highly reliable, and they're designed to carry deckers or vehicles that are almost 1.5 kilometers long. And there are two aspects of this operation, I'd say. One, the commercial aspect of it is it's used to inspect long pipelines, which can be saline water or non-saline water. And on the defense side, these are used to deploy safe charges on existing mines, so those mines are dealt with. So these are the ROVs that are also used for mine countermeasures. Now, till here, we spoke about a human being intervening with a robot so it can carry out the job. So let's remove the human element out of it. So that's basically your autonomous systems. So currently Planis is operating in Gen 4 of its generation 4 of its AUVs, and basically just conducts surveys, underwater sound measurements, bathymetry, etc. So a small detail here. So just like how every object needs some form of locomotion, the main form of locomotion that we have for AUVs and ROVs is propulsion, that is the underwater thrusters. Most of India heavily relies on imports for propulsions, and not just for underwater drones, but also these aerial drones too. Your propellers, your motors, your rotors, stators, all of that. And sometimes the cost of these units, when imported, can be half of your product cost. And so we have indigenized the propulsion as well. So this is our way of helping the country develop autonomy in subsea propulsion, making it available in the market. And one of our AEVs are actually currently in trials with the Navy, and hoping for success. So the way this product is designed is to be modular. What I mean by modular is, like, if you think about it, any ROV or AUV at the end is basically a dead weight that is designed to carry one specific payload. What I mean by that is, let's say if you want to have magnetic measurements, you want to have acoustic measurements, you want to have a sonar to get your bed mapped, everything else, that is your propellers, your bodies, your nose, pressure hulls, everything is designed to make sure you do that one job well. So that's basically how we've planned our AUVs. It's highly modular, whether integrating a magnetometer, your GNSS antennas, RF and VHF, SAT communication, synthetic aperture sonar, multi-beam sonar, imaging sonar, underwater communication, hydrophones. So these are rapidly swappable in field and does not require a lot of mechanical or electronic intervention here. So what you see here is a highly miniaturized version of the previous one. So these are A-size AVs. It's probably, I would say, 2 times the size of a 1 liter water bottle. And this is a fully miniaturized version, and it has dual purpose tech. On the oceanography side, it's used for hyperspectral imaging, coral reef imaging, quick bathymetry. And on the defense side, these are portable, expandable drones, decoy drones. So it's very similar to the aerial warfare we've been witnessing in terms of these swarm of drones that are deployed to misguide your defense systems. The same what you see happening in the air, this is something that does underwater for your torpedoes, your submarines, and things like that. And speaking about indigenous content again, so the entirety of this tail section that is used to not just to propel the vehicle forward, but also manipulate the deviation, the pitch, or the yaw that this vehicle is able to do was entirely designed in-house. And it basically generates up to 4 degrees of freedom, and then your rudders and actuators can move all the way up to plus or minus 35 degrees for your vehicle. When we started developing unmanned systems, the question that we have there is, endurance. How long can you actually run an autonomous system? Can be 10 hours, 20 hours, 48 hours? I mean, that's the limit. I mean, unless if you're talking about Excel units. How can you achieve true autonomy without adding a ton of battery? That's what brought us into developing wave gliders. So there are 2 energies in abundance in the ocean. One is your solar energy, and the other is your wave energy from the ocean itself. That's our inspiration to generate these wave gliders. So these wave gliders are used in subsea warfare, where these are programmed to carry inline towed arrays that are used in surveillance and reconnaissance of underwater objects. And very high level on the other product developments is that we are currently developing an underwater towed probe for the Indian Coast Guard. We we're developing a mid-size AUV for deep ocean missions for MOAs, and we are digitizing the currently existing analog gauges for the Indian Army tanks of T-72 and T-90. I want to slightly touch base on my team's capabilities on infrastructure. So how is Planis doing all of this? So the engineering team, slightly outdated numbers here. Engineering team roughly comprises about 55 to 60 people, and under the umbrella of engineering is mechanical engineering, electrical electronics, manufacturing, and software engineering. And in terms of mechanical engineering, the philosophy that we as an engineering team follow is that we prefer not to buy off-the-shelf products. That might be your hulls, your enclosures, your propulsion, lights, power converters. There might be cheaper options available, but we do it to get better in time, and then this experience that we build over time is what's going to turn into cost-effective solutions. So the thing about using these off-the-shelf units is the power regulators that are commercially available are basically designed for data centers, your benchtop power supplies. Organizations have spent billions of dollars doing this R&D to developing a very stable version that works for very specific use cases. The moment you bring those into place and into an environment like this, it's basically a trade-off. And when we realized that is where we invested huge amounts of time and energy, and we specialized in developing our own power converters, our indigenous BLDC motor drivers, our communications and embedded hardwares. Like, we have had our own set of failures, we've had our own set of learnings. Now we are confidently tailored the product, we have tailored our hardware, and it works best for the requirement. That took time, it took learnings, it took our failures, but we stay consistently through the time. So our manufacturing team is, I would say, 80-85% of manufacturing that you see in our AUVs and ROVs is manufactured by our manufacturing team, and our manufacturing team has the capacity to reach tolerances all the way down to 20 microns. So a bit more about the software team at Planis. So we as an indigenous team, we do not buy software available from the market. So every line of code that you see in the front end and the back end is designed and written in-house. Say over the years, we have been able to create massive amounts of libraries that we have created. That gives us the flexibility for custom deployment here and there. Might be from processing complex sonar data, your cockpit UI, 3D digital twins, and marine autonomy. Every piece of software that Planis carries has been written in-house. I want you guys to slightly focus on this image here. So let's say when we send an ROV for inspection, and there's massive amounts of data that an ROV is gathering. Might be from imaging, might be from sonar, might be from your NDT probes. So when you give that report back to a client, we do not give that massive chunk of data. Unless it's someone experienced, you will not really know what you're trying to explain and what they're trying to understand. So this is what we would do. We have our own in-house software that converts that data into a 3D twin, and basically it gives you a first person's perspective where you will be able to walk around the tank, walk inside the tank, and see up close on what is the health and condition of your tank. It's basically broken down into a color chart, so it's very evident that something in red is not doing well and something in blue is doing really well. So that much amount of complex data is been very plainly dumb proof that's been given out, and this speaks about the user experience that it brings. So I would say our strength is where we have spent years on working on these corner pieces to make electronics, mechanical, and software teams work in harmony. A little bit on our indigenous content is 80 to 85% of content that you see on our AUVs and ROVs have been designed, manufactured, and tested in-house. That might be your subsea thrusters, pressure vessels, antenna enclosures, domes, power converters, DACs, WP stacks, subsea connectors, etc. And with our infrastructure is we have a highly trained group of maintenance professionals that help troubleshoot a fleet of ROVs and handle our operations. And we have a pressure simulator that's been designed in-house that are used to test our AUVs and ROVs for up to 300 to 350 meters. And we have an in-house pool that we use to test our AUVs and ROVs. So with that, I would like to conclude that our mission as an organization has been towards grooming talent in-house and then turning as much as indigenous content as possible to be that true Make in India kind of company. That's all I had. If you have any questions, I'll take it.
Thank you, Vignesh. So, question I just want to appreciate. I'm glad that you're trying to develop your own software and you're trying to make your fabricating yourself, fabrication yourself, and also trying to see the components. It's really a great thing. You have a great vision. I congratulate all of you for moving forward in the last few years to achieve this. Thank you.
Thank you, sir. Thank you.
Thank you, sir. I'd like Dr. J. Pita Roslin to come on stage and felicitate Mr. Vignesh Karthikeyan.
Yes, so basically, you explained very well about the UVs and the systems going around it. I just had one thing in my mind. I was working on research around AUV, right? So there are like two types of system currently. We have like one is the hybrid system through which we control the AUV, or we have like system through which we control the AUVs, right?
So can you repeat that?
Like we have two systems, right? One is the hybrid system where both human is involved and there is an autonomous system which works together to get the task. One is completely autonomous. Like as you see, as you are building it right now, you might know what will actually work in the future. Whether it is autonomous completely, for like because I think like few specific tasks can be completely done autonomous, but there are few tasks which requires human involvement. So how do you think that this particular thing will go in the future? Whether it is going to be completely autonomous in a way for every task that we see, or will it be a hybrid system for what we see today?
Let me just rephrase a question so I get it right.
Yeah.
So you're trying to ask me the question whether do you believe truly autonomous systems are going to take over, or
Yeah,
you still feel human intervention would be required?
Yeah, in a way.
So if you see any piece of software that anybody writes, it's trying to mimic what a human is doing.
Correct.
That's basically how robotics is. It's like even if it is, let's say even if it is a calculator trying to process code, it is basically how you would do math in your brain. That's basically how all of us are writing code.
Correct.
And I would say autonomy is basically the ease of operation. Is like let's say if you wanna run bathymetry for a shipyard, then there are two use cases there. Let's say one is, imagine you deploy a whole team of operation that handles your launch and recovery, and then there's an ROV pilot that's running your operations, collecting data. And the other hand is where an AUV that gets actually deployed goes, does the same thing and comes back. Both the cases are quite different, but yet one does not eliminate the use or true autonomy, I would say. In any given case, it might be subjective, might be might be might be one's perspective, but I believe humans' touch is something that you will never be able to take away from.
But if we know all the parameters, let's say if there is a particular task, okay, this particular monitoring has to be done till this region using an AUV. I know this is the confined task that has to be done. I know all the parameters around it. I know the current status of the oceans, all this data. Then why a human intervention would be needed in such a case?
So most of these autonomous products that are already there, they are well-tested software, well-tested hardware, well-tested mechanical engineering. But if you actually pay attention to the operations, there's actually a board on safety trying to wait. Let's say if something goes wrong, there has to be the team of humans that are used to recover. So there's always this uncertainty inside the ocean. Maybe to help you slightly stitch the answer better is, in one of the examples that Jyoti was saying earlier from NRT, that they were trying to find a missing flight and underwater. So what basically happens is, let's say if it is a water column of 300 or 400 meters, once you drop something at the surface, it's quite literally very hard to predict where that object would go land. That's how uncontrolled, or let's say unprepared somebody has to be when you're trying to handle something in deep waters.
Okay. Thank you.
Thank you.
We would now like to felicitate our two poster juries, Dr. Suchitra D. from SRM IST and Dr. Chellam Malayan from SRM IST.
Now, I would like to introduce another keynote speaker, Dr. Guru Prasad Jaydevan, who is a seasoned marine professional with a career spanning nearly two decades in merchant navy, academic research, and coastal consultancy. He began his career as a marine engineer, sailing extensively on LPG and LNG vessels from 2007 to 2018. During this period, he attained the rank of MEO Class 1 Chief Engineer, developing a deep technical expertise in the engineering management of complex marine assets to sea. Following his tenure at the sea, he transitioned into research at IIT Madras Ocean Engineering Department, pursuing his MS and PhD. His work has been significantly focused on marine sediment transport and shoreline changes. This academic foundation allows him to bridge gap between the theoretical and oceanographic and practical engineering solutions. Since 2018, Dr. Guru Prasad has also served as a director in Indomer Coastal Highways Limited. In this role, he coordinates major international and domestic coastal line projects, desalination plant related studies in port and harbor related surveys and engineering clearance. He also holds a professional accreditations
at QCI NABET accredited EIA coordinator for both purpose and also recognized as functional area expert FAE for risk assessment contribution to ensure sustainable marine project development in the country. We welcome you, sir. Thank you.
So good afternoon, everybody. I think when we began in the morning, Chris was telling that this is sort of coming together of community. So I happened to meet my electrical and electronics professor from BTech. So almost after so many years, he's there as head of MTS. So it was great meeting him. And Dr. Venkatesh has taught me about ocean policy. So it's good that I'm back in front of my professors themselves. Somebody had asked the question, what about this human role? So actually, as part of my PhD myself, I was trying to measure shoreline and what happens to the high tide line, etc. So I wanted to go autonomous, so I installed some cameras to pick up the change in shoreline. And the villagers thought that if there is less sand in front of their houses, government is going to put stones. So they artificially started removing sand from in front of their house. So got totally wrong answers, so I had to come back to manual mode. So in marine field, you always expect the unexpected. That is one lesson that I have learned right from my days at sea. The whole conference is very thoughtfully organized. So far you have seen people with very big, broad visions in the morning sessions telling you where all the field can be, asking you to open up your vision to. Subsequently, you had people telling exactly what sort of things they are doing towards that vision. Then you had the industry come in and say that, these are the sort of equipment we have, these are the sort of robotic items we have. Now you are now left with me, the last guy in the chain. So I am the one who goes to the field, partly uses some equipment, partly tries to fulfill the vision, etc. So this is again an opportunity for you. Do look at it with a very open mind. We provide a lot of consultancy services. A lot of them are very manual. A lot of them do very outdated work. Technology and get into the field. You make my job easy, and automatically you get paid. So normally when I go to present to clients, there is no long building slides. There is no 20-minute presentation. They just want one slide. How have you saved my time? How have you saved my cost? If you can explain that in one slide, the entire consultancy work for 1 year is done and dusted. So with this, I'll just give you a brief about what we do in Indomer, what are the areas that you can look at probably to adapt underwater robotics. So this is Indomer Coastal Hydraulics. We are founded in 1998 by former scientists from NIO. We've done more than 1,000 coastal projects. These are the different areas we work in. We work in seabed engineering, mathematical and physical modeling, surveys, environment impact assessment, ship simulation studies, and chemical and biological oceanography. So all these places are quite ripe. This is our work. We go to the field, we capture the data. So before any hard work is done at sea, we try to show them the depths, we try to show them the seabed, we scan the sea flow for them, we try to find out if it is a magnetic object. So all these right now we are doing using boats, using equipment, using manpower. So if we can come up with technologies that can be automated, that can be done faster, that can be done cheaper, then we have a win-win situation over here. So just to show you the amount of work we've done in the last 20 years, just in India. So these are the number of ports and fishing harbors that have requested our services. So you can imagine the volume of work you would get also when you start providing services in underwater robotics. So the country is too vast, the problems are too complex. So it is a wonderful opportunity for students to start looking at specific problems and trying to solve them. One of the speakers had even pointed out that everybody need not be a scientist and develop everything from scratch. So even adaptation of existing technology to provide solutions are a very good way forward for our country. So this is roughly the mix of projects that we do. For environmental studies, modeling, they occupy the major number of projects. Similarly, the surveys, the measurements, etc. So each of them have a unique challenge. No two sites are the same. No two places are similar. We have to walk into some places in a fisherman's dress to get the work done. And so each place you have to adapt and do this work. And if at all there is something you want to take away from my slide, then I would say this. Always, ocean is quite interdisciplinary in nature. You need to work with other scientists, you need to work with other experts. So though the robotics, the sensors might provide one data, how do you interpret this data? Who interprets this data? How do they apply? So we need to have this skill of working with different experts. So I think when we work in a collaborative manner, when we are open to ideas from other experts, we can do wonders. One small example I would give you, we wanted to monitor dugongs and their mating habits offshore. So one of them came up with the drones that would go and capture when they are coming. There was another team that was trying to capture the underwater noises so that they could interpret when they were, feeding, when they were breeding, etc. So we were doing the task of taking the expert to the site physically to show him what is happening so that he could collate those two data into actually what he is seeing. So these are wonderful opportunities to collaborate and learn something. So though you are from a consultancy field, you get to see different technologies, you get to amalgamate them and try to produce something that is good for the environment and for the nature. Similarly, all these studies which we are right now doing, they are in need of sensors, they are in need of continuous data, because right now we do spatial analysis, temporal analysis, which is too less, but just about meeting statutory requirements. So when we get more data, we can do much better work. So you have in your arsenal all the RUVs, the AUVs. So we need to start thinking, how do we put them together to solve what the industry wants? So by industry, I mean people like us. We want solutions. So when you offer them, we would be more than glad to adapt it. So not just in terms of a big solution or in terms of large robotics, even the smaller parts, what we see is that for lack of unique adaptations, we are not able to do certain works. So we can find out these niche areas, we can improve certain sensors, we can improve certain ways in which data is collected, etc. and interpretation part. So all these things are very good opportunities for us. Of course, as I said, everything boils down to cost. So that's what I put here. If you put my task today as 100%, as and when we start getting better robotics, better methods of doing it, we start cutting down on the cost. So this is something I picked up that there is a tremendous scope for the global marine robotics market. So you are in the right place, you are doing the right thing. And somebody had spoken about the India Deep Ocean Mission. So these large-scale projects are not usually done in one shot. So we have helped NIOT do some small sub-segments of this work. So these sort of massive projects kind of give a fillip to the entire ecosystem in the country. Different people start getting motivated to contribute to such big missions. And finally, above all this, something that is very close to my heart is protecting the blue environment. It is not just about exploration, it is not just about mining, it is not just about cost, etc. We need to get better to map our pollution maps, we need to get better to control erosion, and most of all, we need to get back the ecosystem that is getting degraded due to what I would say, incorrect use by industry. So this is also a place where you have to think, where you can get your robotics ideas and knowledge to work. It would be a great help. Finally, that is the end of my session. As an industry expert, I have just put forth to you that you have tremendous scope to work in this field, and there is a lot more we can do when we work together. So thank you for having me here. Thank you.
Thank you, sir, for the presentation. I would like to invite Dr. R. Vegetation to felicitate Dr. Guru Prasant Jaya. I'd like to call up Mr. Chris Hostander to felicitate.
The last keynote speaker for the day, I would like to call upon Mr. Muni Venkatakrishna, who is an Indian entrepreneur, technology innovator, and startup founder, for his work in robotics, drone technology, and sustainable mobility solutions. He is the co-founder and CTO for Zero Robotics Private Limited, a company that focuses on developing advanced robotic systems, electrical propulsion technologies, and sustainable marine mobility solutions. He has been actively involved in building deep tech startups and has contributed to the areas such as marine robotics, electrical propulsion systems, and drone-based technologies. Mr. Venkat Krishna is also associated with several technological ventures and serves as a director in multiple companies working in robotics, aerospace, and technology innovation sectors. An alumnus of the University of Technology, Sydney, he has been recognized for his entrepreneurial contributions and innovations in the emerging technology and sustainable engineering solutions. His work mainly aims to focus deep tech innovations on smart mobility and robotic-driven solutions that support sustainable infrastructure and future technology ecosystems. We welcome you, sir. Thank you.
Good evening, everyone, and special thanks to Dr. Prisarolin ma'am for inviting me here, and thanks to Chris sir for making a wonderful presentation today. So today I'm very excited to talk about biomimicry in underwater robotics. So I'm Muni Venkatakrishna. I'm CTO and co-founder of Zero Robotics. Actually, here we are doing multiple verticals. One of the verticals is underwater ecosystem. In underwater ecosystem, we mainly focus on underwater robots, AUVs, and gliders. We plan to make indigenous components in-house. Next. So first, I like to explain more. I like to explain about what biomimicry means. So what biomimicry means? Nature itself is having many like way of life forms where we can able to grasp the actual life forms, from where we can able to learn more about how each system is going to work. So we can able to have design inspired from nature itself, because nature itself has been solving many problems from billions of years. So by studying the nature itself, we can able to implement those principles in real-time engineering applications. So by understanding more about engineering aspects, we can able to understand the engineering problems and solve by increasing the efficiency, energy consumptions, as well as aerodynamic shape, which we can able to solve it from underwater coral systems itself. So I would like to call nature itself as a original designer, because across all the industries we have been seeing many industries where underwater systems and underwater systems as well as humans are trying to utilize birds and battle bees itself as a special way of having special design where it's wing itself can able to fold into a compact wing called eclipse. So by seeing the bees itself, we can able to design aircraft systems as well as satellites we can able to deploy in outer space. So these kind of biomimicry systems can be inspired from actual nature itself. So today we can see more about ants and fishes. Even we can able to get inspired from mosquitoes. So by mosquito needle means we can able to insert it without painless actually. So this things can be inspired from mosquitoes and bees and many more applications. So if we can see the examples of the biomimicry, here this is the ladybird bee where it can able to fold its wing under the protective sheeting. So same like that we can use this concept in aerospace. In outer space itself, all the spacecrafts as well as satellites can utilize this concept in deploying the actual satellites in the real-time environment. And if you see the Japanese blood train, it is actually inspired from kingfisher bird. So it's in the shape of the kingfisher nose. So by mimicking the kingfisher bird, it can travel like high speed. So same like that, belugas is a white whale. So Airbus is being inspired by belugas. So it's named after that. So this Airbus can carry a large payload capacity. With this design concept, it is very hydrodynamically efficient, as well as it can able to fly, with the low energy itself, it can able to fly for a longer time. So if you see other designs compared to this Airbus model, it can other models can carry less weight, but this kind of Airbus can carry even aircraft itself with its nose being in the shape of the belugas. So biomimicry is the future of marine system. Means so nature itself has been continuously providing us with more information than we actually do it in a lab. So over the million of years, all the creatures, underwater creatures itself has been evolved, and if we carefully study about the dynamics of each creature, we can able to understand more about how it's efficiently moving under the water. If for example, if it's a manta, it can able to glide it and it can able to move. All the maneuverability will be easily done in the underwater systems. So we can easily utilize our principles in adapting those kind of manta fishes. So this will increase efficiency of the underwater systems, and also maneuverability, agility, and everything can be studied from the underwater creatures. So as I said in the previous slide, this is the manta. So if you see the flying, if you see the wing, it can able to fold and lift its body entirely with this. So this can able to quickly, it can able to maneuver in a tight environment. So if it's a confined environment, also it can able to easily maneuver with its wings. So it utilizes low energy. It is same like a glider. How glider will it utilizes this propulsion system and propel itself with the lowest energy. Same like that, this mantray will utilizes less energy through glide to the water. So we can easily mimic this kind of principles and adapt it to our underwater ecosystem. And one more example is that the dolphin wings itself is designed in such a way that it can able to aerodynamically rotate at higher efficiency. So a team of engineers have already utilizing the design concept of whales and utilizing this design concept in the wings of the turbine. And one more example is that snake robot. So how snake robot can help us to mimic means in a small space where it's hard to maneuverable. This snake robot can able to easily go and do its survey inspection and come out without any dirt environment. So this kind of agility and maneuverability also can be for a tight space environment where complex systems needs to be deployed. This kind of underwater robots help us. So these are a few examples for the biomimicry design. So moving on to our next slide, this is our indigenously developed underwater robot. As I said, indigenously developed. So this is it's like a platform on which we can able to add sensors and everything to it. So this was inspired by turtle actually. So it will be in the shape of the turtle. So how the turtle can move and do its maneuverability. Our ROVs also can able to do its tight maneuvering by it has an auto thruster configuration, so we can able to move quickly, and the turning radius of the ROV also can be very quick. And from by sparing from the turtle, it can able to quickly maneuver and do a tight operations, which can able to attach many sensors and robotic arms also can be attached with the system to do small minor repairs and systems. So how we ideated our design from biomimicking the turtle's movement to final design means by creating a ideation stage where we bought all the conceptual design thoughts and we created a conceptual design where we same like automobile field, we sculptured the model with a clay model and how the dynamics can be helped, how the hydrodynamic can help the robot minimizing the energy, so it can able to outperform its endurance as much as possible. So from this is you can see the final model bottom side. So that one is the final iterated model. So before that we had multiple iterations where each one had different challenges in overcoming the turbulence of the water and getting all the each design helped us in improving the design much more. And we also have three patterns on this underwater ROV system for modularity and highly maneuverable with low energy consumption, high efficiency. So as Jyoti ma'am in the previous session told us, so we are actually official NAOT industrial partner. So we are doing one of the projects for NAOT where we are doing the underwater robot, quadruptic robot, which can able to walk on the seabed floor. Also, it can able to glide the underwater system. So this will be attached with the mansub Marcia. So where it is going to deploy it from the mansub, and it's going to monitor all the coral reef system. And once all the data has been captured, it will automatically surface back to the Marcia itself for charging and data transfers. So we are also working with the NIOT for a wireless communication system, as well as for the we are literally developing each model. So these are a few of our projects where we have delivered our intelligently developed AEV and USB. So USB mean generally everyone is working on metal composites, metals, but we are actually working on composite manufacturing. We are very expert in composite manufacturing, where we can able to combine different material concepts by decreasing the weight and increasing the strength. With aluminum, if you compare with the carbon fiber and other composite manufacturing techniques, we can able to if you take a traditional AAV and compare it with ours, so traditional AAV will have a payload, say for example 5 kg means by changing it to composite frames and everything, we can able to achieve more payload, like 7 to 10 kg we can able to increase the payload. So slowly we are also indigenously developing underwater cameras with underwater lights as well, which can able to we can able to have a depth rating of around 650 meters. So we have already tested it with the NIT testing tank and up to 65 bar pressure. And with the surface vessel, US vessel, we are also working with NIT for the autonomous swarm project. So where we initially plan to deploy it on the rover vehicle, where we will monitor the autonomous waypoints and do the missions. We will have the edge device installed in the rover itself, where each rover will each rover will have its own intelligence and communicate with the ground station. And after the initial test, we actually implemented this into our USV, so ground vehicle, unmanned surface vehicle. So where we have tested it in our Madavaram Lake, where we have got the initial readings for testing the swarm algorithm. And once all the iterations has been completed, and we are also building PD algorithms for the AV swarm robotics. So once it's completely done, we will be implementing those in the AV, which will be the final one. Also, we are working on homing and docking station for the NIOT, where as Jyoti ma'am said previously, they will be deploying the homing and docking station at 50 meters depth rating. So under 50 meters depth rating, as ma'am said before, we'll be using the acoustic communication for navigating the vessel up to a certain distance from where we can able to see the light. So through visual confirming, we can able to identify with the YOLO model, and we can able to navigate the AEV back to the homing station. Actually, if you want to speak about homing and docking and navigation, the AEV is going to deploy from the homing station only. So already the AEV knows its home location. But why we are going to use light as well as other form of systems to navigate back to the same homing station means all the other environmental variables will make the error. See, if even the IMU compass where the accuracy is 0.2 degrees means if the AEV is moving more than a kilometer long, and if it's coming back to the same point means there will be error accuracy. So these systems has to be depth rating can be easily monitored from the depth sensor. So by combining all the sensor data, so it will navigate the AEV back to the homing end station. So by this, I concluding the presentation, and thank you everyone for giving the opportunity to present this slide. Thank you.
Thank you, sir, for the great presentation. We would like to call up Dr. J. Preetha Roslin to felicitate Mr. Mohana Krishna.
before we begin the valedictory, we'd like a few people for feedback, please.
Anybody wants to give the feedback regarding the technical talks?
You can come to the dais. Come on to the stage.
The event was very good, and all the sirs and were very good, and the speeches were very good. It gave some very good innovative ideas. Thank you.
According to me, the session, the whole day, when first it started, it felt a little slow, but as we paced up, getting into the keynote sessions, like a lot of different industry leaders came on and taught us a lot of different things. It felt very good, like, okay, we are getting something out of the industry, and that is what we want at the end of the day. And I participated in the poster competition. The feedback was good, the results were good, they were understanding our particular problem statement that we gave and solution that we proposed. That was very good, and apart from it, the way they approached us also was good. And overall, the event was well organized according to me. And thank you everyone for the organizing team. Yeah, thank you.
Anybody else from the outside colleges, outside from SRM? Anybody?
We will now proceed to the valedictory ceremony. We will begin by appreciating the MTS Nanda participants with a participation certificate to all teams, presented by Dr. Napoleon, Dean of Research, SRM-IST.
First up, we'd like to call up from Juniper Institute of Technology, Indigenous Development of Low-Cost, High-Accuracy Doppler Velocity Lock DVL for autonomous underwater vehicles and AUVs. Could the whole team please come to the dais? Indigenous Development of Low-Cost, High-Accuracy Dopplers. Could you guys come to the dais? This is the participation certificates for all the NAMDA participants. Next, I'd like to call up Aqua Sweep, solar-powered autonomous aquatic waste collection robots from SRM-IST. Please make your way to the dais. Next up, we'd like to call up IoT Hydrella, real-time water quality monitoring using an IoT-based underwater CANSAT from Juniper Institute of Technology. Please make your way to the dais. Next up from Sona College of Technology, AI-enabled smart coastal erosion monitoring systems for real-time shoreline change detection and early warning. Please make your way to the dais. Next up from Sri Ramakrishna Engineering College, advancing circular in ship recycling, smart recovery, and reuse of aluminum scrap. Please make your way to the dais. Next up from Sona College of Technology, AI-powered smart buoy networks for early detection and real-time monitoring of coastal water pollution and oil spills. Please make your way to the dais. Next up from Ahmed University, Poseidon. Precise oceanic structure engagement with intelligent diagnostics and operational networking. Please make your way to the dais. Next up from SRM Institute of Science and Technology, drone rover hybrid system for marine monitoring and coastal surveillance. Please make your way to the dais. Next from SRMIST once again, design of a CubeSat with bidirectional SEPIC-based EPS along with battery management. Please make your way to the dais. Next from SRMIST, cast crabs for autonomous swarming technology. Please make your way to the dais. Next up from MEPCO, Sujit Hariharan. Please make your way to the dais. Thank you, delegates. We now request Dr. J. Preetha Roslin, to announce the MTS Nanda Award winners. The winners will be appreciated by Mr. Chris Ostrander with cash prizes and certificates.
So all are excited about the winning announcement. So there are two things. One is for MTS Nanda winner announcement, and then it is being followed by a poster winners announcement. So Nanda winners, they have been waiting for a very long time since the competition happened. No results have been declared, but we have invited all the participants for this event so that we want to appreciate their works. So I'll start with the third prize. The third prize goes to two teams. One is Drone Rover Hybrid System for Marine Monitoring and Coastal Surveillance from SRM Institute of Science and Technology, Varun, Nitishri and Sharon. And third prize, we have another person also in the category, another team, because we are so, we want to appreciate the students well, so that it is not like one single first prize, second prize, third prize. We have multiple teams in one category. So another team who is bagging the third prize is Design of CubeSat with bidirectional CEPIC based EBS along with battery management. That's from SRM Institute of Science and Technology, Sri Soumi. Now the second prize go to Ahmed University. The topic is precise oceanic structure engagement with intelligent diagnostics and operational networking. Mr. Aditya Mahadev, Vijay, Bocha Narayanamurthy, and guided by Bharati Raja and K. Karthik. You can come up with your mentor. The second team to get the second prize, it's Sona College of Technology. AI powered smart wire network for early detection and real-time monitoring of coastal water pollution and oil spills. Tigan Kannadasan, Neha Prapti, Palnishami, Adi Keshava Sundarajan, and mentor is Mr. Naveen Kumar. The third team to get the second prize is Sri Ramakrishna Engineering College, Krishna Kumar, Jeevan Vishwa, Anish Ravi Kumar, Satya Seelan, guided by Dr. Bhagyanathan. Topic is advancing circularity in ship recycling, smart recovery and reuse of aluminum scrap. prize winners. There are two teams who are bagging the first prize. One is from SRM Institute of Science and Technology, Car Scraps for Autonomous Farming Technologies by Aparajita Paul, Jitesh, Melvin, Ramachandru, Nitin, Vasant, Vishal and Ramachandran. The second team to bag the first prize is Gargir Hussain College of Engineering, Aligarh Muslim University, Amri Bari, Mohammed Bilal, Tanishka Bharadwaj, Supreet Chaudhary, Divyatshi Gupta, Abdullah. The topic is Physics Informed Neural Radiance Field for Turbid Water Inspection using an 8-thruster AUV. Thank you. We now appreciate the timely help delivered by our poster juries in spite of their busy schedule, and we wish to felicitate them by Dr. R. Venkateshan, Founder Chair, MTS India Section. Dr. Salim Anwar Khan, Aligarh Muslim University. Dr. Guru Prasad Jayadevan, Indomer Coastal Hydraulics. Mr. Muni Venkata Krishnan Gopinath, Zira Robotics, Private Limited.
We now request Dr. C. Nitya to announce the poster competition winners, and the award will be provided by Mr. Chris Ostrander.
Third prize goes to SRM Institute of Science and Technology for the title Intelligent Control Algorithm for Underwater Multi-Agent Robotic System, and the teammates are Aparajita Paul, Jitesh and Ramachandran. Please come to the right. Second prize goes to Jerusalem College of Engineering for the title Sagar Vigil Warrior, and teammates are Akalya, Saumya, Soundar, Parani Bharati. First prize goes to JPR Institute of Technology for the title AUDAPS, and the team members are Anara Salba, Sujata, Ahil and Crispin.
Thank you. We would now like to invite Dr. Napoleon, Dean of Research, to deliver the vote of thanks.
Good evening to everybody present here. First of all, I would like to thank our management, respect Vice Chancellor, as well as Registrar for providing all the support to conduct such program. And I would like to thank the Dean, Dr. Vijay Kumar, Head of the Department, Dr. Sridhar, and the organizer of this one-day symposium, Professor Peter Roslin, one of the dynamic professor from the EEE department. I think she has been doing a lot of things. I was surprised to see her presentation at the NIOT last year. She presented very well. Everybody appreciated. I hope she will do something better with the help of the EEE student as well as PhD scholar. I think I also thank Dr. Venkateshan, founder chair, MTS intersection. He is no presence here, and he has been doing very well for the student community as well as many people know about the Marine Technology Society. That's very important area. Even our community also pointed out that we are still lacking behind the blue economy, right? We are not extensively using like some other country. Hope this kind of one-day symposium initiated by Dr. Venkateshan, who is the founder chair, and he is very enthusiastic and was telling about how he is supporting students, and almost all the students got some prizes. That's motivating you people to do something in the marine technology, which is marine, no? So you have plenty of opportunities out there. So thank you for choosing SRM University and for providing this opportunity. I think we are there from first one who will join with MTS from 2014 onwards. Thank you, sir. And also I would like to thank Dr. Mr. Chris Ostrander, CEO Marine Technology Society. So we came all the way from Washington and traveled to India first time and motivating, giving talk to young buds. Please give him a big round of applause that he spent 2 days time for traveling. Again, he is going back for 2 days. And all the way he spent, I understand his involvement in this MTS, and he wanted to see people and motivate you. And thank again Professor Peter Roslin bringing such a dynamic people here. I hope you will all get benefit out of that, and use some of you, please make use of it and use this technology for move forward. There is a big ministry, is the Ministry of Earth Sciences, so they have been taking care of the marine things. So they have plenty of money, and they are giving a lot of fund for the deep ocean mission and then the pollution. Now the temperature has risen, and also pH has risen. So these are some of the environmental related issues. Also, every year they said if you leave the marine for some time, after 50 years, you will find more plastic than fishes. So I think this kind of the symposium will be helpful to bring awareness to the students. Again, thank Ms. Chris for coming over here and enlightening our students. I would like to thank, I think, Professor Salim from Aligarh Muslim University. I have one friend, Dr. Munir. I know him more than 27 years. He is from Chemistry Department. He did his AVH Alexander Humboldt Fellowship. It is one of the prestigious fellowship. He got it and he went to Germany and worked with Professor Bondeman. He is one of the outstanding guys. One of the articles got 25,000 citations. So he wrote with him, I know each other. I visited once. Thank you, sir, for coming over here and then participating and some of the awards. I will also thank all the organizers who are involved in this one-day symposium, especially from Civil Department and all the student participants from all over India. I'm happy to see from Aligarh University, Sona University, as well as Jerusalem, right? Almost they covered almost all the main universities, and they came over all the places and actually participated and got some of the awards. I hope all of you got benefited out of this conference. I also thank all other non-teaching staff who are involved in that one. And once again, I thank the organizer, Dr. Peter Rosling, for organizing this kind of event that I hope that definitely to bring some kind of awareness to the student who don't know about marine. So it is plenty of opportunities are there. Please you focus on that. I think you will do wonders. Not only you can use AI also. I surprised how the EEE will be involved in the marine technology, but she is doing very well. That means AI also you can use it. So I thank you for giving the opportunity to be here. Once again, thank all the organizers, participants. I wish you all the very success. Thank you.
Thank you, sir, for your kind words. Please all rise for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तब शुभ नामे जाहे तब शुभ आशीष माहे गाहे तब जय दाता जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
Jerusalem College of Engineering, Akia Soumya, please come forward.
All participants, Poster competition participants will get their participation certificates from the registration desk up front. All MEP participants may go back for refreshments. Poster participants, please take your posters off the poster boards as the poster boards will be moved soon. Please take your posters and then get your snacks and certificates. Organizing team, please remain back for a photo session. Organizing team, come back after snacks for a photo session.
Poster team can have your refreshment first, then you can take off your posters, and while going to home, collect your certificates from the registration desk.
Speak. Shortcut to the right noise passing.
Who is talking what? Hey there, hi.
Nitya, can I cut the screen?
फिर भी